Hello, everyone. So a few notes before we get started with Kian. We do have a code of conduct. We want everyone to feel safe and welcome and have a good time. If you have any issues, if there's something happens, please feel free to reach out to James. James, could you stand up? Yeah, okay. And then Kleena, over here. Could you wave, Kleena? Cool. So you know who to reach out to if that happens. Let's get started with Keen. Keen-O-Mad.
Thank you. I like very dramatic music. So, hi everyone. Keen is my name. So I just want to say a few words before we kick off today. I originally started this crazy conference in 2012. And this year is 2022, so I suppose it's like a 1 and a 0 onto 2012. So who would have thought we would have been here 10 years later? So it's funny how things happen. We ran the original Node.js meetup in Dublin in 2012, and the morning after one of the first meetups, I was talking with Anton Wally, who's around there somewhere. And we were mad hungover, we were in that kind of horror zone of hangover. And I just booked my tickets to go to NodeConf in Portland, Oregon, and I was giving out about how long the flight was and that there wasn't a conference here, and then the two of us looked at each other and went, yeah, let's do it, let's make NodeConf happen over here, you know. And it's just been a lovely, it's been a really nice experience from, literally having no idea what we were doing, saying, yeah, we're going to put on this conference. We had no money, we had no idea what we were doing, and but yet we were like, we should make this happen because no one else is doing it. And myself and my business partner at the time, we had to get a €50,000 bank loan, personal bank loan, so that we could afford to run the conference. And we just pulled it together. It took us 14 weeks from the first, from having that idea to running the conference. And actually the first conference was in the Guinness factory in Dublin, so that was kind of a first as well. It's definitely the first JavaScript conference in a Guinness brewery ever, So it's just kind of gone from there, it's turned into a yearly thing. There's a lot of people I really love here that I've met through the conference, and there's some people that have been at every single conference, I think, yes, including myself. But it's just a nice thing, You get all these people who are, from different parts of the world, different backgrounds, and technology is the thing that's brought us together. And we get to go to this conference in this obscure location, and it is intentionally difficult to get to, because if you really want to be here, you're not going to come here unless you really want to be here. It's too much of an undertaking. So we try and kind of create a space then for the week where there aren't too many talks. We don't want to do that to people, and there's plenty of time to hang out together, And one of the things that I think is it's a personal a success metric for me is when somebody that attended a conference a couple of years ago ends up being a speaker a couple of years later, That's a lovely thing, so, as all of you kind of spend your time here today, look at the people around you, you make unbelievable friends and connections and all that, and you might be on stage next year, or the year after or whatever, and, we've a couple of people here that are, I don't know what we call them, alumni speaker, I don't know, Illuminati. But yeah, it's really nice to see that. And I suppose the final thing really is just about being nice to each other. For me growing up, a small town in the southeast of Ireland, I was one of those kind of smart, quiet kids who had a tough time at school and all that kind of stuff. And I think there are a lot of people similar here, and you have this lovely thing where you have a conference which is about technology that brings everybody together, and that should be celebrated because, you know, for me anyway, I still live in a small town, and nobody has a clue what I'm talking about most of the time where I live, you know. But when I come here, like, I meet people who get me, like, and I get them, you know. So being nice to each other and being respectful to each other and making a safe environment is so important. Like, you know, it's a really lovely thing. So that's it. I hope you all have a nice time, and yeah, I'll see you around over the conference. So thanks, guys.
Cool. So next up, we have Liz Parody. She will be talking about Node. Come on up, Liz.
Thank you, Tierney. Yes, I'm going to be speaking about Node. So welcome, everybody, to NodeConf Europe, and thanks for attending to my talk. I will be talking about new and exciting features in Node.js. A little bit about me. I come all the way from Colombia, South America. It took me a while to get here, but I'm very happy to be in this beautiful place with all of you. I'm head developer advocate at FuseBit, which is a company that does integrations for developers, and I'm a community leader, speaker, Node.js evangelist, blogger, dancer, and even though my last name is Parody, I am not really good at making jokes, unfortunately. And this is my Twitter, Liz Parody, and FuseBit Twitter. If you want to have any questions or if you want to chat, you can contact me there. So these are the 5 features we're going to see today that you should definitely try. So the first one is Test Runner. Then we're going to see Watch, Stream Accessors, Argument Parsers, and Undici. Raise your hand here who has used these 5 features. Yeah, a few of them. Nice. Who has used 3 of them? 1? Cool, most of you. So in this talk, you will have a basic understanding of these features so you can get started and take advantage of them. So the first one is Test Runner. So we can all agree that tests are very important, but before Node.js version 18, there was no third-party, there was not like a test runner out of the box that supported Node.js. So developers needed to use third-party testing frameworks such as Mocha or Jest to do unit testing. But using a third-party framework can add some complexity to do your environment configurations, CI/CD, workflows, and maintainers overhead. And also, it could be challenging which tool to choose because some of those frameworks are like very great to set up very quickly with minimal effort, but they don't have async testing or auto-mocking, or they're not very complete. And there are other frameworks that are the opposite. They have everything. They're very complete. They have async testing, auto-mocking, but they're not as easy to set up. So yeah, it has these trade-offs. So every developer to do tests in Node.js, they needed to install its own test runner. So it just made sense to create its own test runner inside Node.js core. And by doing this, the intention was to enable a limited subset of the functionality provided by most test frameworks in a lightweight manner. So all of you can get started very quickly. You don't have to install anything, and you just add functionality as stop as is needed. So how does this work? In short words, you can do tests in Node.js without any npm packages. You can use the module node test and --test to do some basic searching and matching in test files. It's recommended to do assertion with the module node assert. And just as a fun fact, they took inspirations of building their own test runner by Dino, because Dino has its own test runner. So the people of Node.js were like, well, I guess we can also have our own test runner. Well, I think they didn't exactly say it like that, but kind of. And also, they took inspiration for Happy Lab, for Mocha, and Jest. But in Jest, it actually took inspirations of things not to do in a test runner. For example, injecting global variables automatically and execute code in different... Oops. Hello. Oh, yeah. It's back to normal. and execute code in different contexts because it can have unexpected results and outputs. So I'm going to show you very quickly how the test runner works. So here we have the most basic test. We have test from NodeTest and assert from assert. And we're just saying that NodeConf is a cool conf, and we're just testing that this is true. So if we do, we just see that one test passed and it's all good. And now all of this is inside Node.js, so you don't have to install anything, which is super cool. And for example, if we want to see how it failed, we just see NodeConf is a boring conf, and we just see that it fails. This is the actual and the expected, and yeah, it has some warnings and some trace. So yeah, this is very cool. And you can also skip tests doing this, skip option with messages, and this test will be skipped. And you can also do subtests. So here we're just measuring that 1 is strictly equal to 1 and 2 is strictly equal to 2. And for more advanced functionality, you can do module interception with the modules of proxyquire and smog, spine and stubbing with Xenon, and standalone snapshot with snapshot assertion. And just with everything in Node.js that is still experimental is recommended to not be used in production. And just like at any test runners, promise rejection, error throwing, don't call back, not invoke, they're all treated as failures, and you can use node test as the module and run the test with node and the file name. And also you can do node -- test more options to run multiple files at once. So the second feature is watch. This is super exciting. I really like this one. Is automatically restarting the Node application when it detects file changes. So last year, Node.js tweeted about which single tool have you found to be the most useful in your day-to-day JavaScript authoring experience. And a lot of people replied, NodeMon. It has 5.2 million weekly downloads. So basically, the watch mode will watch the entry point of any required or imported module, so you don't have to stop your server and start again once your file changes. If you just do node -- watch index, your application will automatically refresh just as using NodeMon. And you can use -- watch path to see which path is being observed. Also, this new flag cannot be combined with the flag check, eval, and interactive on the REPL. It just won't work. So that's it. Now you can use node watch index or your file name to start watching your files without having to install anything. But actually, you cannot use it yet. It's going to be ready like in a couple of days. So yeah. Extreme accessors. So it's basically now you can use map, filter, and reduce inside streams. So streams have a reputation of being very hard to work with and even harder to understand. But they are one of the fundamental concepts that powers Node.js applications. They are a data handling method used to read or write input into output sequentially. So they're very good for writing or reading files, for network communications, for any end-to-end information exchange. And what makes a stream unique is that instead of having all the file load into the memory all at once, like in the traditional way, streams are very powerful because they can read chunks of data piece by piece and processing its content without keeping it all into memory. So this makes a stream extremely efficient to work with large data set or a big file. Because, for example, a file size can be larger than your free memory of space. So this makes it impossible for the file to be processed because there is not enough memory. So this is where streams comes to the rescue. By having a small chunks of data, you can be able to work with a big amount of data and big files. So for example, Netflix or YouTube or other streaming services, what they do is instead of giving you all the content at once, they give you small pieces of data so users can start consuming straight away. So that's why it's called streaming services. But streams are not only good for large files, but they also give you the power of composability in our code. And designing with composability in mind means that you can have different combinations of components and to have the exact same output. So with Node.js, you can create this composability using streams by piping data into another. And you'll be wondering why people should use the streams. Well, mainly for two reasons. One is memory efficiency, and the second one is time efficiency. Memory efficiency because it takes, is more efficient for the memory because you don't have to load all the file into memory at once to start processing it. And time efficiency because it takes significantly less time to start processing a file as soon as you have it, instead of have to have all the payload to process it. And there are 4 types of stream in Node.js. Writable, which are streams that you can write data, and with fs write stream, you can write data into streams. With readable, you can read data from each chunk of streams, and I'm going to show an example. I'm going to actually use the readable streams. And with fs read streams, this is how you can read data from streams and all content and everything. Duplex is both writable and readable. And transform is that you can modify or transform a file that is being written or read. For example, an instance of file compression. You can write compressed data and read decompressed data. But streams has been around for a while, right? But what is new and what is exciting is that now you can use map, filter, and reduce inside of each chunk of a stream. So let's see how this works. So here we have readable, which is one of the 4 types of streams that I just explained from Node streams, and resolver, which help us with the DNS promises. And we have a chunk of readable, and we're just reading these 4 numbers, and we're going to map those 4 numbers to be multiplied by 2, and we're just going to console log this. So this is how we read data from streams, and we map it. And resolver, here there's another example. We are reading from these 3 web pages, Node.js, NodeConf EU, and FuseBit, and we're just going to map those 3 web pages and see the end result and how long it takes. So if you just do node. So this is it. We can see how streams are being mapped and the results of those 3 web pages. And filter is very similar. It's a very similar example. So we're just doing imported readable, resolver, and we have these 4 numbers, and we're going to filter by the number that is bigger than 2, and we just print it out, is 3 and 4. And also here, we're just reading the same 3 web pages, and we filter by like the web page that takes more than 60 milliseconds, and we're just going to print that in the console log. And reduce, we just have readable, and we are having these 4 numbers, 1, 2, 3, 4, and we're just going to do a reduce, like we're going to sum all of these numbers, and if you just do reduce, just see 10. So this is very cool. Before you couldn't do that, but now you can do map, filter, and reduce in streams. Okay, the next one is argument parsers. So now you can parse CLI arguments. So there was a really long discussion inside Node.js of how there were multiple modules that handle parsing of CLI. For example, Commander, JS, and Yarks to create programs inside CLI. And yeah, like the Node.js contributors were like, this is very useful, a lot of people use it, maybe we should have it inside Node Core. Because, for example, Commander had 93 million weekly downloads. Commander just looks after parsing the arguments into options, and command arguments displays usage error for problems and implements the help system. And Yarks, it has 70 million weekly downloads, like just a few weeks that I checked. And it helps you build interactive command line tools by parsing arguments and generating an elegant user interface. So now, with util.parseArg modules, we see that this was merged a few months ago. And as we can see in the description, it adds util.parseArg's helper for higher level commands like argument parsing, instead of interacting with process RGV directly. So it takes the expected arguments and returns a structured object with the parse options. So how does the parser work? So it does not execute functions. It does not check for types, not TypeScript, not anything like that. It doesn't allow you to define types, and subcommands cannot take options that are distinct from the main command, so only the main command matters. And -- would signal the end of the options that are parsed into the parser. So let's see how the parser works. So, important parts are for node util. And here I just have 4 options. So the name, nationality, dancer, and gamer, and we're just parsing those options and print it in the console log. To see this, we just do node, and then I just do name, Liz, -- nationality, Colombian, -- dancer. I like to dance, but I am not a gamer, so I'm not going to pass anything there. So if we do this, we can see all is printed here in the CLI. So this is also very cool. And as you can see, this is how if you want to have the exact same output before, you will have to do all of this with processes that are RGV, and yeah, it's more complicated. You have to replace and split, and this can have it open the doors for vulnerabilities and bugs, and it's more complex. But now you can see it's way more clean and easy, and you can parse those arguments in a better way. And another cool thing is that the native module is not going to replace the existing packages. Instead, it will empower them to easily catch those CLI arguments and perform complex operations. This was said by Eric Wendell. And finally, Undici. Undici is a spec-compliant HTTP 1.1 client that is written from scratch and represents the evolution of the Node.js HTTP stack. So I really like the documentation because Undici means 11 in Italian, because it's HTTP 1.1 is 11 and Undici. And it's also a reference of Stranger Things. So you'll be wondering, why Undici? Like, Node.js has already HTTP stack that works very well and is all good, people use it, so why to refresh and create something all the way from scratch? The reality is that the HTTP stack in Node.js have some fundamental design issues that are impossible to resolve without breaking the API. There are certain bugs and performance bottlenecks that will affect the majority of the users, both in the client and in the server. So the team behind Undici decided to create a fast, reliable, spec-compliant HTTP client for Node.js. Some important features about Undici is that it keeps alive by default. So you don't have to install a keep alive agent. You have LIFO scheduling, which is last in, first out. That is very good for minimizing the time errors, timeout errors. No pipeline by default, but you can configure your own pipeline. It has unlimited connections and can follow redirects and opt-in. So there are important things to understand about Undici, like mocking, redirects, and proxy. But because of the length of this talk, I'm just going to talk about mocking. Because Undici reinvents HTTP primitives and relies directly on sockets, mocking approaches like knock won't work. But luckily for all of us, Undici comes with its own built-in mocks. So we can test against Undici. So I'm going to do an example with dogs. Let's see how this works. So here we are requiring requests from Undici instead of HTTP. And we're just going to get a breed of dogs that we're going to see this web page that lists all the breeds of dogs. And also we're going to get some images of those dogs. So we get those images, and if there is an error, we just throw the error. So this is the dog client. And the test, we can see this is the test for the dogs. We just hit the first test, we just see that it returns a list of the breeds. And the second test, we just we're just looking for the images of the dogs. And then we just catch if there is an error or anything. So we just have 2 tests of the dogs. And finally, Undici mocking. So this is how mocking is made. Mock agent is the basic entry point of the mocking system. So this is how you import it. And then we have intercept that is used to build the mocks. We have the path and the method and the reply. And finally, we just check there is an image path is valid. And we will have the message and some images of the dogs. We check if the image is valid and some to check for errors. And if we just do, oops, hold on. Well, it was working a few moments ago. But this is basically how you do mock in Undici. And because we're talking about pictures with dogs, this is my dog. I found him in a lake. He was very tiny and very little, but now he's very big. He grew up as big as a cow. He's gigantic. And some conclusions about exciting features in Node.js is that first, the contributors in Node.js are always looking to improve the runtime, as we can see with these 5 exciting features that I just presented, but there's other exciting and experimental features that you should check out, like async hooks, diagnostic channels, trace event, web crypto API, WebStrips API, and WASI, that is WebAssembly System Interface. So this is it. Thank you very much, and thank you for the organizers of this conference, and also for the Node.js contributors that are always looking to create and make Node.js better. This is my email, my Twitter, if you want to contact me, and I hope you enjoyed the rest of the conference. Thank you.
Great job. Some really exciting features. I've been using test a lot myself. So as Cody gets set up, I did want to talk to everyone about a general social thing that we can all do to help everyone kind of feel more included. So quick show of hands, how many people are familiar with the Pac-Man rule? Okay, like 20, 30. So the Pac-Man rule is a concept where if you're sitting in a group at a bigger part of the event, everyone's talking, always leave like a little slice, like a Pac-Man mouth open in that group, and that will help, show people that they can come in and start joining the conversation and participate and feel welcome. So yeah, if you're in a conversation with a bunch of people, make sure you step aside and leave a little bit more room for people to join. Cody.
Yes.
You ready to talk about full stack JS?
I am so ready to talk about full stack
Great.
JS.
I'll leave it to you.
Thank you so much. How's everyone doing? I'm so excited to be here and so excited to follow that great talk, details about Node.js and the new features. I'm going to step back and take a higher level approach and start talking about how we could build like a full stack application today in 2022. And spoiler alert, it's going to talk about Fastify and GraphQL and some really awesome stuff. So I was thinking about Kian, who gave the opening keynote, talking about people here who are in the audience, who are now up on the stage. So I came to NodeConf in 2017 and 2018 just as a guest, and here I am on the stage. So I was thinking about Kian when he said that. Thank you, Kian. I'm a developer relations engineer at Nearform. And also, I teach a web development course at the local university where I live in France. So first thing I want to do is do an exercise with everybody here. I want you to close your eyes and imagine your next project. You got all the requirements from the stakeholders. You understand basically how long it's going to take. You're going to maybe do an agile, or maybe you're just going to make a quick proof of concept and build on that. You got a general idea of what the project's going to look like. When I do this, I inevitably start thinking about all the new technologies and the new frameworks that I'm going to reach for to solve all those problems that I had in my last project. And what I tell myself is, this time, it's going to be different. This time, it's going to be right. This time, it's going to be rainbows. And this time, it's going to be unicorns. And inevitably, what happens, though, is I get like 80% of the way through my project, and everything's going great, like development velocity's like so high, taking off like a jet airplane, and all of a sudden like something happens, like we hit this like brick wall. And this brick wall is generally like this last 20% of those non-functional requirements, those hard requirements. You already have code that's in production, you're trying to add things for security, authentication, authorization, all these things that weren't just like those functional requirements that were kind of like the easy part, right? It's that last hard 20%. So in our head, we're thinking rainbows and unicorns. In reality, we find ourselves somewhere like this, like down in the nitty-gritty, getting dirty, trying to fix things. There's production code. There's stakeholders that are calling. You're still like trying not to add too much tech debt into your project. So I feel like there's this massive gap between how we imagine our project and reality. Because we're just real-world people. We're devs trying to fix real-world problems. So what I want to do is think about that last 20%. And I use this percentage a lot, 80-20. And we call this the 80-20 rule. That came from this dude, Vilfredo Pareto. He's an Italian economist, and he had the Pareto principle. I know you can't read that quote yet. He said, maybe like 80% of our outcomes, just roughly 80% of them come from 20% of the requirements. If we're going to look at this like in a project perspective. So there's the whole Pareto principle. And I think Steve Jobs knew this because he left or got removed from Apple. He came back in 1996. They had something like 15 desktop models, cut them down to 1. They had a whole bunch of portable devices. I think back in the day we called those laptops, cut them down to 1. Peripherals, printers, just got rid of them all. Like he focused in on that hard 20%, like the core 20% of the project, or of the business in that case. So that's what I want to challenge us to do today when we try to build a tech stack, a modern tech stack today in 2022. Let's focus in on that hard 20%, and maybe, just maybe we could gain like 80% in our productivity if we take that into account from the start. So how can we build a tech stack today that's going to work for the real world if we focus in on that last 20% of those non-functional requirements that are going to be hard? To do that, I want to lay out some principles. And the first principle I'm going to look to when I build this tech stack is going to be modularity. And I'm talking about modularity in my tech stack. I want to be able to swap out layers in my tech stack if a technology is not working the way that I need it to work for my project. I think this is really important because sometimes those frameworks claim to do everything. And when they can't do everything, are you going to throw away like your whole project or like 80% of your tech stack? That's not going to work. So I want to see modularity in my tech stack. Next up on my principles is going to be developer experience. And I'm not just talking about modern APIs or your fancy pants CLI tool that's supposed to make your life a lot easier. I want to talk about code that can run anywhere, like in the cloud or on my dev machine. When I'm in the clouds, 30,000 feet above the air in an airplane where I don't have a good internet connection, or if I'm in a train where my internet's like in and out, or I'm in a hotel where like they say they have Wi-Fi. We're pretty lucky here. We have amazing Wi-Fi. So I want my code to run anywhere. For me, that's developer experience. I want to be able to run my end-to-end tests in an airplane without an internet connection. Next up on the principles, community. I want to see open source projects, 100% open source, community supported. When I have an issue, I want to be able to go and search like GitHub, find other issues, talk to people about this, get involved in the community, see if anyone else has had the same problem with me. I don't want to be relying on some sort of paid support package where I have to call and talk to my account manager to get support. And you know, more eyes on the code, in theory, in general, it's going to be more secure, right? Like that's why we love open source projects. And like I said, 100% open source, not just 80% open source and 20% of the magic secret sauce run in some cloud service that we don't have access to. So my last principle is going to be transparency. And transparency can relate to open source, but I'm also thinking about transparency when we talk about abstraction layers. So we all know, we all love abstraction layers. That's what makes us productive as developers. But sometimes abstraction layers don't work for our use case, or for our requirements, or for our project. So I want to be able to peel back the layers of abstraction and be able to get my fingers down in the nitty-gritty, into the dirty parts of the code if I need to. Like abstraction layers shouldn't get in my way. They should make my life easier, but I should be able to move them aside if I need to. So now let's talk about the stack. And I think one of the traps that we fall into when we're designing a full stack project is we're going to start from the front and we're going to work our way to the back. So I want to turn that idea inside out, upside down. Let's start from the back and work our way forward to build this tech stack. So now I'm going to talk about the stack. You're going to see this picture of waffles a lot in my slides. It's like a stack, and they look kind of tasty, so you'll see them a lot. First up on the tech stack, we're starting all the way from the back. My friends, take note of my Twitter handle. You can flame me, send me your hate mail. I'm strong, I can take it. But there's an elephant in the room. The elephant's name, Postgre. Yep, I'm not talking about a fancy cloud-based database service. I'm talking about Postgre. Why? Because it's the best relational database. I'm saying it right here on the stage. And I'm willing to bet in this audience, anyone who has a computer science degree or an software engineering degree, willing to bet money, quote me on this, I'm willing to bet money that you've taken a relational database design course. So devs know it today and they can build systems with it now. Like that's what's amazing about using a relational database is that you don't have to ramp up your whole team in some new technology. Like I said, it is the best relational database, but if you want to go like documents, you can do it, right? Like Postgre has amazing JSON support, started like in version 9, and now we're up to like 14, or there's like the 15 release candidate, and each time like the JSON support gets better. You can do indexes, aggregations, you can do all kinds of amazing stuff in JSON. So if you want to work in like a document-based style, NoSQL style, Postgre lets you do it. So it's your choice. It supports connection pooling. So if I'm building a modern full stack application, I want to be able to scale. I want to be able to scale massively. And for scaling at huge amounts, every CPU cycle becomes important, right? And if our application, our server is trying to connect to the database with secure connections, there's a lot of overhead, like TLS handshaking, all this stuff. So if we can reuse connections, do that connection pooling, this can be like a huge difference in big big applications that scale to huge size. Developer experience, it runs anywhere. I can spin up a Docker image of a Postgre database on my machine here in like less than a second. So I can do that. I can run my tests in the airplane. I can populate my database, run end-to-end tests, easy. And again, love it or hate it. And it's a love-hate relationship for me. SQL is crazy powerful, right? We can do aggregations. We can do joins between different tables or collections if we want to talk about document-based storage. Like SQL lets you do it. So it's a love-hate relationship, but it is super powerful. Next up on the tech stack, we're here at NodeConf. We're building a web server backed by Postgre. We're going to be using Fastify. Mateo's out there somewhere. Fastify. If we're going to build a web server in 2022 with Node.js, it's going to be Fastify. I couldn't help but think about that cat munching on some of those tasty-looking waffles. It's inspired by Happy. It's going to be really familiar to Express devs. So if you've done other kinds of cloud functions or serverless functions, you're going to feel right at home. And inevitably, like your code base is going to evolve. Maybe you start with like a proof of concept, and maybe you're building a monolithic application today, but as like your project grows, complexity grows, Conway's law, eventually like your code base is going to resemble your organizational structure. And you know what? Fastify like evolves with you and your team and your project. You can split your code out into services or into plugins. You can isolate things. It supports that. Fastify, surprise, surprise, it's fast. It supports insane scaling. That's one of its superpowers. And of course, just like Postgre, it can run anywhere, locally, in the cloud, anywhere you want it to. And I mentioned real briefly that it does have a plugin architecture, and this is really programming Zen because you can isolate your plugins and decide like an API for ways for requests to access shared data that should be accessed from different plugins. So this is one of the amazing things about Fastify. And now, if we're building a web-based application, we have Fastify, we have Postgre, we need to have like an API server too, right? And I already gave away the spoiler, it's going to be GraphQL. And if we're doing Fastify and GraphQL on the server, we're going to be using Mercurius. And Mercurius is a plugin for Fastify that is a GraphQL server. And it's going to solve like real-world GraphQL challenges like right out of the box today. And when you like load it up in your application, if you run like the quick start, it comes with all those things built in. So I'm talking about caching. And Mercurius can do caching. It can hash your query string plus the variables to build like the key into a hash map, and it can cache things in memory. Or with like a plugin, you can connect it to a Redis database. And now you could have like a shared cache. If you have like a cluster of instances, they could use like a shared cache. So this can be really important when we're talking about scaling a big service in the cloud. And supports federation. So if you want to have like a GraphQL gateway, you want to maybe federate your schemas between different servers. That supports authentication, subscriptions, file uploads, all those things you didn't think about when you built like your proof of concept of your GraphQL server. Like it supports those things like out of the box. And we're going to talk about developer experience. Integrates the GraphIQL developer console, so you can load that up in your browser. You can go and investigate your schema and your APIs and debug your queries. This is really great if you're like giving a GraphQL API to another team. They could just run it in debug mode, activate the GraphIQL server, and they can start debugging and investigating the schema themselves. And lastly, it has the loader support built in. And we call this like the N+1 problem. But inevitably, your data is a graph, but we can also look at it like a hierarchy. You're going to have parents and children. And if you've ever written a GraphQL server, you write these functions called resolvers for each node in the graph. And the first time you do it, you're going to like fetch all the parents. And for each parent, you're going to run another query to get its child. And with the data loader support, you can aggregate all the IDs of the parents and then convert that into one giant SQL query, get all the children. So now you've gone down to 2 queries instead of N+1 queries for each parent. And you know what? If you're interested in some of that, just have a little plug, because at 2 p.m., we're going to do the GraphQL workshop. And one of the things we're going to talk about is the data loader support So if you want to know more about that, be sure to come to the workshop this afternoon. Next up on the tech stack. So we are at NodeConf, talking about Node and servers, but I have to talk a little bit about the front end too. And if we're doing GraphQL on the server, on the front end, in the client side, we're going to be using Urkel. I call it Urkel. Maybe you call it URQL. It's amazing. It's a GraphQL client, and it's going to be compatible with all the major front-end libs. I'm going to focus on React, but it's worked with other libs too, and it supports caching. Caching is amazing in Urkel. It can do just like Mercurius, where you're going to hash the query and the values of the variables to build your key into the cache. It also has this plugin called the Graph Cache, which actually normalizes your data. So if you have one query that gets a bunch of data, and if you configure the Graph Cache correctly, it's capable of finding like entities in your data based on its type and its ID. So now you can have like 2 different queries accessing the same entity, and the cache is smart enough to say, oh, I already have that entity in the cache. I don't have to pull it from the server. If you do that, and you store like your cache in like IndexedDB inside your browser, all of a sudden you have like amazing offline support. So if you have a spotty internet connection, you want to build a web app that on portable devices that may not have constant access to the internet, like it supports that. You can build some really cool possibilities with that. If your connection gets lost, you still have data in the cache. You can actually write things into the cache and synchronize it back to the server once the connection comes back online. And it supports subscriptions, uploads, all those things that you're going to need eventually in a production app. It has this exchange architecture, which is what they call plugins. So this helps you, extend Urkel the way that you need it to. And it's compatible with SSR. Developer experience. If we're talking about React, it has a hooks API. I'm going to show you that in just a second, which is just programming Zen. And they have a DevTools plugin for Chrome and probably the other browsers that lets you see your queries going by in real time and debug them and check the performance between your queries. So it has everything you need from one project out of the box. So I know we're at NodeConf, but I have to bore you with a little bit of React code. Here I'm going to build an application. We'll call this my pizzas application. And inevitably I'm going to have like a page where we show all the pizzas. We're going to have a list of pizzas. If you click on one of those, you'll see the details. So here's my React component for that pizza list. There's actually one component. I split it into 2 code segments to fit on the screen. On the left-hand side, we have the query, the GraphQL query. I'm just querying all the pizzas, the pizza list. And on the right-hand side, we have our component, our React component. And on the second line, we have the use query hook. This comes from Urkel. And you can get a result object. You can destructure that. And with that, if you have an error, you could do something. You could redirect the client somewhere else or display an error message. The fetching variable, if it's like taking a long time for your query to access the server because it wasn't in the cache, you could show a loading spinner or something else. And then finally, you could render out the data. So the API, this hooks API from Urkel, is just really React compatible and React Zen. So that's the pizza list. Here's the pizza details. Only thing really different is the query. Because before I was getting all the pizzas. On the left-hand side of my query, I'm getting one pizza by ID. On the right-hand side, we have basically the same code, right? Use query hook, and I'm just showing a pizza details a little bit different. And what's going to happen if I've configured my graph cache correctly with Urkel and in Mercurius, when I do that pizza list, here I called it pizzas just to fit on the screen, it's going to work its way down the server, get the data out of the database, but on its way back, things are going to get stored in the cache. Now here's where the magic happens. When I want to click on one pizza and see the details, if I've configured my graph cache correctly and Urkel knows the entity for that pizza that I want to see details is already in the cache, it comes right out of the cache on the client side. No trips to the server. So this is like some amazing performance that we could get when we're building a GraphQL application here in 2022. So if we take that in mind, we have the graph cache from Urkel, and we write our GraphQL APIs to match our business domain. So we're thinking already about how the use cases of our APIs, and we're using a graph cache. Graph cache is kind of like a global state, right? And maybe we don't need global state. And maybe we don't need Redux when we're writing React code. And that's how I feel. Every day I write React code and I don't have to use Redux. Yeah. So we are at NodeConf, and I think I'm running a little bit short on time, so I'll speed up a little bit. But it wouldn't be right if I didn't mention React. That's the last part of the stack, because it's React. Like, everybody's using it. Devs know it. You're going to be able to ramp up your team, scale up your team. You're going to need to learn a lot of new skills. That's why I love React. It's evolving, yet it's stable. Version 18, we had some surprises, but we've accepted those now. It's going to encourage you to split your code into components. And we can, with the hooks, we can now write all functional components, because nobody really wants to use classes because, prototypes, JavaScript. Let's just write functional code. That's what we love about React. It has the dev tools. If you have written a React application, I know you have the dev tools installed in your browser. Vite, if you're not using Vite, just use it. It's so fast for packaging, bundling your code. Works with ESM modules. Just use it. It's amazing. So I wouldn't be doing this talk justice if I didn't mention at least SSR. And if you're going to be using this tech stack with Fastify React, and you want to do SSR, you should be using Fastify Vite. This came a project from a previous colleague of mine, Jonas Galvez. It's going to work with all the major front-end libs. I'm going to focus on React. It's going to handle page-level templating, right? Because eventually your page is broken into different parts. And usually I kind of integrate this with your React router on the client side. We need to do that on the server, too, when you're rendering things on the server side. So it gives you an API to do that. Also, it's going to integrate the client-side routing into the Fastify server. So normally you define all your routes on the client in your React router. We need those routes on your Fastify server, too, right? So when they navigate to some deep page that normally the client side would have handled that route, the server needs to handle that now, too. So it gives you APIs to do that. And all the abstraction that it does, like it's just these APIs, they're really customizable. There's no magic. You can see all the code. If you're doing it with React or some of the other front-end libs, Jonas Galvez also made Fastify DX, which is like a turnkey solution for building an SSR app using Fastify and React and some other front-end libs. It's still an alpha, but if you're looking at doing SSR, you're interested in the stack, check that out. So in the beginning, I was imagining rainbows and unicorns. That's probably not realistic, right? I think we use a good stack. We target that last hard 20%, the non-functional requirements. Maybe we can't handle them both, but maybe we could still have some unicorns. That's how I feel when I'm coding with a tech stack like this. So real quick to review, why do I love this stack? Because it's built for that last hard 20% right from the start. We're thinking of that right from the beginning. We want an app that's going to scale. It's going to have ways to have security built in. It's built for that complex functionality. The abstraction layers, they're there to help you, and they help you in that common use case, but you can peel them off when you need to. There's no magic behind the scenes, and it's highly customizable, right? It's a modular stack. I didn't present one framework that does it all. I presented a lot of different technologies to build a modern stack. And of course, all those projects are 100% open source, 100% community supported. That's why I love them. That's why we're here at NodeConf. That's why we love Node, because of those reasons. But now I need your help. We had the lean stack. We had the mean stack, the jam stack. What's my stack? Best I came up with was Frump, Fastify, React, Urkel, Mercurius, Postgre. It's kind of awkward. Murph, Firm, that was awkward too. Still looking for a good name. Send me a tweet if you got a good name for my stack. I'm just having a hard time coming up with something that has a good ring to it. And of course, I wouldn't be doing this talk justice if I didn't mention I work at Nearform, and it's an amazing place to work. We get to contribute to open source. They're sponsors of some amazing projects, tons of downloads, over 1 billion monthly downloads on NPM. But we're also a professional services company, so we do consulting work. So we get to walk the walk and talk the talk at the same time, which is pretty unique because we're really involved in open source, but then we apply that to some really cool client work, building some really cool projects. And we're always hiring. So if you want to talk about that, hit me up. We got a booth too. Hit any of us up. We'll be really glad to talk about it. If you see Open Source is Art t-shirt, thank you, Nearform. Ask us about it. I'd love to talk about it. I have to give a final plug in my last 20 seconds. GraphQL workshop is at 2 p.m. Looking forward to seeing a lot of folks there. Your life's going to be a lot easier if you have Docker Compose, and LTS Node version of Node installed before you come. If not, we're all going to be like fighting for Wi-Fi. Actually, the Wi-Fi is really good here. But if you have time, make sure you have those things installed before you come to the workshop. That Pizzas application, you can check it out at this GitHub repo, just like a proof of concept showing how that could work. And there's also links to these slides. So that's the end of my talk. Thank you so much. I don't know if we have, I guess I'm out of time. I don't know if we have time for questions or not. If not, send me a tweet or come see me anywhere and come to the GraphQL workshop. Thanks, everyone.
I'm excited to see what you come up with for the name of that stack. It's gonna be special. You need to add another vowel.
That's the problem, right? There's too many consonants. So.
Yeah.
Yeah.
We'll figure it out.
I'm counting on you.
Oh God.
No pressure.
Cool. So another piece about today. Tonight at 8, there's going to be 2 coaches coming to the main entrance. Those are going to be taking us into town to Billy Burns. It's a pub. It's an Irish bar. If you haven't signed up, you should probably have an email. I know I got one saying like I opted out of Nearform emails a while ago, and like they were asking if I wanted to opt in. I said yes. But yeah, if you haven't signed up, there should still be room. But that's part of the plan tonight. The buses get here to the front entrance, not this entrance, the front entrance, probably where you came in at 8. At 7:30, there's pizza. Like in the lobby, there's stairs that go up into a patio area. So there'll be pizza there at 7:30. Yeah, so if you weren't aware of the Billy Burns stuff, that's happening, show up to the front entrance at 8. I'll let Robin take it away from here with some new nice JavaScript stuff.
Yeah, thank you. Yeah. Thank you, Tierney. Yes, I'm Robin. I'm going to talk about future JavaScript stuff and most likely immutable data structures. So before that, hi, I'm Robin. I work at Bloomberg in a team called JavaScript Infrastructure and Tooling. I actually happen to have some colleagues here with me today, so you can chat with us. I'm also a TC39 delegate for Bloomberg. We'll get into what that means a bit later, but I get to participate into JavaScript standardization. And I'm also a co-author of the record n-tuple proposal, so we're going to talk about that today. And again, I'm not alone. I have one of my co-champions here in the room. So yes, so record n-tuple. We're going to first go back to object types, how they're being referenced, how they are mutable today, and we're going to see on what is an advantage of that and what is an issue about that as well. Then we are finally going to get to talk about record n-tuple. So that's going to be the big chunk of the talk, and then we're going to talk about when can you actually use it and related proposals. So let's go into it now, and let's talk about object types, references, and mutability. So you already know objects, you already use them today. That's the same with primitive types. And so let's talk about primitives first, right? On the first line, I'm creating a string here. On the second line, I'm also creating a string. Whether those two strings are equal or not, that is the question. And they are equal because they contain exactly the same sequence of characters, so that makes them exactly the same string as far as JavaScript is concerned. Okay, however, what happens with an object with a key that contains a certain value, and what if you create 2 of those objects and the key and the value are exactly the same? Well, they're still different because objects are being referenced by a reference that is being stored into those 2 variables. So the first object is different than the second object, and so that means that those 2 things are not equal as far as JavaScript is concerned. At least they are not strictly equal. And now let's talk about mutations. So you can try in strict mode to mutate some character inside of a string, and you'll see that you'll get a type error out of this. This is completely expected. So that means that over the lifetime, you cannot change what the value is for this specific string. For objects, that's different. Like, you probably already mutated an object in your life. This is a very common operation that you're going to change a key here. And that's fine. That's what we expect objects to do. And I think this is something that we have also seen recently, is people starting freezing objects. This means that essentially your object is going to be shallowly frozen, which means that you cannot change any of its keys. So when it comes to that, this is very interesting, but it's not deep operation. So this array inside of the object is itself not frozen. So in that case, that's a good thing, because I wanted to add my colleague Ashley. Actually, that's going to come later, but yes, in that case, I wanted to add Ashley to the list of my champions, and that's actually going to be an operation that will complete correctly. Okay, so this kind of creates a problem, because some of you have been dealing maybe with configurations or things that you don't want to get to change over the lifetime of the object. Right? For example, if I have this initialize connections function that I actually don't exactly know what it's doing, how am I guaranteed that it's not going to change what's in DB here? And the answer is I don't know unless I open the code for init connections. So maybe it will not change things, because that function might be actually nice and not do something crazy with the object, but it could do something crazy with the object I'm passing it to. And that is even if I freeze it, right? Because again, freezing is shallow. So what we could do is this. Yeah, it's not great. You're basically outputting a string and then you're parsing it. It's not good for CPU, it's not good for memory. So if you really want to do something like this, please use structured clone. It's available in Node, it's available in most modern engines, and it's going to be a little bit more efficient than this, but if we could avoid this altogether, that would be really great, right? I wanted to also point out another problem with objects that we have today is that it's basically back to their referential aspect, the fact that if you create two different objects, they will never be equal because they are two different references. So here we have a nice boat with a really nice name, with really normal coordinates to actually say where the boat is going to be located. And we're going to start mapping out in an ES map the coordinate as a key to the location, to the boat itself. So this is OK if I reuse the exact same coordinate object that I had originally, and I use it for the lookup. I will find my boat. But let's say I create a copy for some reason, or I recreate manually the coordinates. So I get a new object. And this new object reference is not usable to do the lookup. Even if the value inside of the coordinates object are exactly the same as the original one, this lookup won't succeed. OK, so let's use JSON stringify again. It's really useful. I could just stringify my coordinates here and stringify my coordinates here. I have two strings that are equal. It will look up correctly, right? That's fine. Well, this is very, very shifty. So we could get in a situation where the insertion order, for some reason, is inverted. So in that case, well, the lookup will fail again. And this is the kind of really hard to track bug, because, yeah, I'm serializing it to a string. It should work. But since the object is insertion ordered indexed, you're going to get in some situations where you're going to print two objects that have exactly the same values, but differently. So that's not great. And also, you cannot have object cycles. You cannot, get to a string unserializable, etc., etc. So to recap things, when you have primitives, it's really cool because you hold values, and you cannot mutate them. When you have objects, it's a bit more complicated. I mean, you get references to those objects, and you can actually mutate them if you want to, unless you freeze them, and if you freeze them, it's only shallow. So that's one thing to keep in mind. Okay, so this is the moment where I conveniently introduce record and tuple, and that's a good thing because that's the talk today. So that's a record. It looks like an object, except you have this hash character in front of it. This is going to make a huge difference. And so this is a tuple as well. As you can see, hash character again. This is an array literal. You put a hash character in front of it, you have a tuple literal, right? And you can combine them, right? This is a tuple of records. And now you have the other way around, where you have a record that can contain tuples. And you can do any combination that you want. The cool thing about them, at least for our purpose today, is that they are immutable. If you try to change a key of a record or a tuple, it's going to get you a type error. And it's a deep immutability. If I'm trying to change a record inside of a tuple, like I'm doing here, well, I'm also going to get a type error. Now, let's talk about equality, because this is very important. In the two first lines, I'm creating two arrays on the same line, and I'm comparing them. And they're obviously not equal from JavaScript's perspective, as we explained earlier. Same thing with those two objects. They are not equal. That being said, if I add the hash, then I get records and tuples. So for example, in the example of the record here, I'm associating the value 1 to the key A. And so if I have another record that's associating the value 1 to the key A on the other side, they are equal, because this is the same value as far as JavaScript is concerned. And same thing, if I put the two same sequences of 1, 2, 3 on both sides with a tuple, I will get the same equality. Because record and tuple are indeed primitives. So if I do typeof on them, I will get typeof of a record is record, typeof of a tuple is a tuple. So let's go back to the issues that we had earlier, right? So the first problem that we had was this deep kind of configuration. Well, since we're fully immutable by default, I'm pretty much sure that init connections, if it tries to mutate my configuration now, it will fail at doing so, and it will raise a type error. So if I get to the assert here, that means that that's it. It's done. We managed to go through it without any mutation. And I don't even need to know how init connection is written. I will just know that since I passed it records and tuples, it didn't modify them. Now let's talk about our boats again. So now I'm just going to change my coordinate system to use records instead of objects. And that makes a whole difference, because now my copy essentially will have the same latitude and longitude values inside of it, which means that my second lookup now can succeed, because the map is going to compare the records by value instead of comparing references as it would do with objects. And so this is really practical. So talking about object cycles and unserializables, those cannot really exist in record and tuples. We don't have to really think about them. But what about the key ordering that we talked about earlier, right? That should be an issue. Well, the very interesting thing that we did is that, because we foresaw that it was going to be a problem, records are not insertion ordered. So that means that every time you're going to compare two records, whatever the insertion order you did on them, they're still going to be equal. And as a matter of fact, if you run object.keys on them, it will always return things in lexical order. This is unlike objects. If you run object.keys on objects, they will give you keys back in an insertion order. So this is really cool, but we have to kind of pay the price of them being records and tuples semantically. So the first consequence is that you cannot put objects inside of records and tuples, because if you would do this, they would not stay immutable. And so if you forget to put a hash in there, it's going to give you a type error. And that's kind of what we want, actually. Like, I don't think it's a drawback. It's just, it is very clearly a trade-off we're making here. that is a bit more annoying, I would say, that you cannot actually reference functions inside of records and tuples. And the reason for that is that functions are actually objects. So since you cannot put objects inside of records and tuples, well, you cannot put functions inside of records and tuples. We do have a solution to kind of reference them in a practical manner. That being said, this is way more scope for this talk. And so if you want to know more about how we plan to do this, you can go and talk to me. So now, we have another issue, is that since everything's completely immutable, and some of you that have been doing functional programming already, you already know how we get out of there, but let's go through it. If I want to add Nicolo and Ashley to the champion group today, the tuple here won't let me call push on it, because push doesn't exist on a tuple. Why? Because push is changing arrays in place, so we couldn't port it to tuples. So how do we do this? Well, you could just use spread. Spread will work correctly, and it will basically get you from one tuple to another tuple, and then you can spread those two tuples into another tuple. You get a new version that has the new values added to it. And so that will work consistently across arrays and tuples. And so you can also spread arrays inside of tuples, and you can also spread tuples inside of arrays. You can also do the same with records. Like you would just do with objects, you can spread. And so that means that if I just want to update one key, and so I want to keep those two, like the current state of the proposal and the next state of the proposal, because we're not yet there yet at the next step. I'm going to get there later, but right now the proposal is at stage 2. Hopefully soon it will be at stage 3. Before we can say this, we still need to keep the old version here. So we created a new copy and we changed the value essentially. So beyond spreading, we have different things that we want to do. For example, on array, you have array prototype.reverse. And reverse is interesting, but it also changes things in place. So we cannot, again, change the tuple in place. So we created a new method that's called toReversed. And that instead of changing the tuple in place, it will apply the reverse operation on the tuple and return you a new one. That's it. It's as simple as that. So we have toReverse that is reverse but not in place. It returns a new tuple. We have toSorted that's doing the same thing as sort, but again, not in place. It returns a new one. And we have .with that's doing the equivalent of an indexed assignment. So this is essentially going to do the same operations as using the brackets. And finally, we have toSplice that's doing whatever Splice is doing, and I'm not going to go more into details about Splice. Okay, so this is really cool. So what would be even better is that if we had those functions with arrays, and well, we kind of wanted to do this, and so we added them in another proposal. So that's it. I could write this sort by name function that you're seeing here that's going to work on either array of or tuples being passed down to it. So if I pass a tuple to this function, it's going to work. If I pass an array, it's going to function correctly as well. So we have Rick and Ashley here passed as an array of objects. And here we have Rick and Ashley passed as records and tuples. And I'm very sorry, but that's the joke. You're lucky because I couldn't get the rights to put it like in audio for everyone here. So, but I hope you have it in your mind playing now. Okay, let's do a quick summary. You add a hash, you get a record or a tuple. That's simple. They are immutable. They are actually deeply immutable, and then if you want to update them, you can use spread or tuple methods that are also available on arrays and typed arrays, actually, I forgot to say, which means that you can write interoperable code. Then, instead of referential equality, you get value equality. And that value equality happens at all levels of the language, including, obviously, strict equality with triple equal, but also in ES maps and ES sets that will actually use the same semantics across the board. And they can't contain objects or functions inside of them, but we might have a good way to reference objects and functions inside of records and tuples in the future. So what's the state of the proposal? Because some of you might be anxious to use it. So record and tuple is a stage 2 proposal at TC39. What is TC39? TC39 is the standardization venue for the ECMAScript language. The trademark oracle for JavaScript. And stage 2 means that out of 4 stages, it means that the committee expects the feature to ship one day. So the basics on the proposal have been agreed, and we're just trying to define it clearly right now. And we did a lot of work to define it pretty well. So the proposed spec is being reviewed at the moment. We have already 2 out of 3 reviews that have been finished. We have a Babel transform and a polyfill for it. We have started on test262 spec test. They are not integrated into the test262 test suite, which is the standard test suite, essentially. But they're ready to be integrated. There is a Firefox implementation behind the compile time flag in Firefox that I think now is also supporting JIT optimizations. And so what does that mean for you? When can you use that feature? Well, for experimentation, we want you to try it now. Like, take a picture of that URL right now and go there and try things out because this is the last moment we can get feedback from you, because once it gets to stage 3, it's going to become increasingly more complicated to make deep changes to the proposal. So that being said, experimenting is fine. Using the feature in your projects is really dangerous because, as I just said, stage 2, things can still change quite a lot. So that means that it's definitely not stable. And what about the new array methods from change array by copy that we showed you earlier? Well, I'd say you can use it for new projects now because we have polyfills that are available. It's shipping in Safari right now. It's also shipping in Bun, if anybody cares about it is in NodeConf, but you know, since it's using JavaScript core, it's in Bun. It's also in SpiderMonkey, but behind the flag, unfortunately, but it should be switched off quite soon, switched on quite soon. And for V8, work is being tracked actually, and the V8 team is actually working on it. So it's hopefully going to be available in Chromium and Node and Dino soon. So for existing production projects, I would just wait because you might not want to work against polyfills for existing projects. That being said, I'm almost at time, so I want to thank everyone that worked on this. Like, I'm not the only one working on this, far from it. First of all, we have Rick, who's been my co-author from the beginning of this proposal. He also wrote the playground that you're going to try, and Rick is also in the room. So if you want to ask questions about record and tuple, is absolutely super knowledgeable about it as well. So don't hesitate to go and bother him. Sorry. And Dan, who's not here today, but also works at Bloomberg, has been our mentor throughout the process and been reviewing the early drafts. Then we also have Nicolo, who's working at Igalia and also is a Babel maintainer. He has been reviewing our spec. He also has been doing most of the first implementation for SpiderMonkey in Firefox. Ashley, who joined Bloomberg now that joined our champion group more than a year ago now, I think, has been working a lot on finalizing the spec, has been doing an amazing job. That's very difficult because spec text is an animal on its own, to be clear, and has been finding a bunch of edge case in our proposal here. And I wanted to thank also a few of the implementers that have been working on it. Tim from Igalia has been taking up the JIT work for the SpiderMonkey /Firefox implementation. And Aditi has been implementing change array by copy in JavaScript core, so that's why Safari is the first browser to ship it, but that's really cool. Finally, I wanted to thank you here at NodeConf EU for your attention today and listening to me talk about new stuff. So I'm Robin. I work at Bloomberg. You can find me on Twitter. You can find me on GitHub. You can find Bloomberg at this address, but you can also find us at the booth that we have here at NodeConf. And yeah, come talk to us. We are obviously recruiting, and we are also super interesting to talk about anything from Node, obviously, to JavaScript standards, web technologies. Yeah, we're pretty much interested in all of that. If that's it, I can, yeah.
So we are running a little bit ahead of time. Every speaker was like doing great. So we have some extra time before the break starts. Well, the break starts now, but before the coffee and the smoothies are out. Our next talk will be at 11. We're off until then. At probably 10:30, 10:25. So in like 5-10 minutes, the coffee and smoothies will be out. Tea as well and fruit, I believe. But yeah. Enjoy some time and talk amongst yourselves. Cool. So next up, we have James Snell. He'll be talking about Node as well, surprise, but he'll specifically be talking about a Abort controller. So give it to you, James.
All right, hello. First of all, absolutely fantastic. I love being back in Ireland. Love this event. It's one of my favorite ones. It was one of my first Node events back in 2015. And just, I mean, so excited to see you all. So many, familiar faces that I haven't seen for so long. It's great being back here. So, what am I going to talk about? I'm going to talk about a little experiment that went wrong in Node. I love talking about bugs, especially ones I added, right? I always had the joke that, with all my Node contributions, I add the bugs, and other people come along and fix them. It's my contribution to the community, bringing more contributors into the project. In this particular case, I'm proud to say that the contributor that I brought into the project was my own son, who is here, who joined, came out with me. So it was kind of a fun thing to do. But clonable abort signal, or how I created it, caused a major performance bug in the fetch implementation. How are these connected? Kind of, what was going on? That's what we're going to talk about. First, who am I? I'm James. J.A. Snell, for everyone who knows me on GitHub and Twitter. I've contributed a few things to Node over the years. The URL parser, web crypto, HP2, abort controller, web streams, a few other things. My latest small contribution is a 38,000-line PR that is adding quick. So a few small things. I also work at Cloudflare. We recently, just last week, open sourced Workerd, which is kind of the core part of the Cloudflare Workers platform, where you can run it locally now, so it's not just limited to the edge environment, so it's something fun to play with. I'm not going to be talking about that here, but if you want to talk about it, grab me anytime at the, out and about, and I'll happily show you some demos of that thing. It's pretty cool. And this is Lala. She's my COVID puppy. I miss her. She's at home. We have 5 dogs altogether. I say, well, we have 5 altogether. My wife has 4. I have Lala. So, yeah. Okay, so a while back, there was an issue opened in the Undici repo talking about fetch performance parity. Basically, what this was looking at is, Undici did the implementation of fetch. It's what we use we pull that into Node, and that's how we get fetch in Node now through this. But when we first started looking at this, it was like, okay, how well does this perform? And it was found that it performed really badly. It was very, very slow. And this issue was open to start taking a look at what those issues were. Ethan's going to be talking about the fetch a little bit more, but importantly, the fetch implementation makes use of the new readable stream and writable stream, that's the web streams APIs that are in there. Specifically, when you create a new request object or response object, right, you're creating this writable stream or readable stream instances, right? And that's key, particularly the writable stream part. Folks testing this discovered that just creating these objects were really slow. It may be hard to read, but what we're seeing up here, if we look at this P99 percentile, just to create a request object that was not being used, in this benchmark was taking about 12,000 milliseconds, right? When they created a standalone test that wasn't using this, doing the exact same thing in this simple bespoke version, it was only taking 25 milliseconds. Slight disparity, right? It was kind of an ouch moment, right? So why the hell was this so slow? And I don't expect you to read this flame graph at all, but it turns out what this is telling us is it had absolutely nothing to do with fetch itself whatsoever. What this is telling us, right in here, what you can't read it, is that creating an abort signal as part of creating the request object is what was so slow. That's what was slowing it down. Fetch uses writable stream. Whenever a writable stream is created, an abort signal instance is also created, whether you're using it or not. Okay? So per the API with request, you can actually pass in an abort controller or abort signal so that if you want to cancel the fetch operation, right, you can just use that abort controller.abort and signal that it should be canceled. If you do not pass that in, an abort signal is created automatically for you anyway. So there's always this abort signal instance that is used inside that, inside that writable stream, inside that request. Okay, so it's always there. Just creating the object creates the abort signal. And just creating that was very, very, very slow. All right, so why was it creating, why was this slow? Again, nothing to do with fetch whatsoever. It actually had to do with another experiment, another bit of code that I contributed, I think it was 2020, on a completely unrelated topic, all right? We have this idea of cloning an abort signal, and what do I mean by cloning? So if you are using worker threads in Node, right? And you want to send a value from one worker thread to the other, right? You're using the post message API, right? You create the other worker, you want to send an object over, post message, that object, and it's sent. What's actually happening under the covers is this algorithm called the structured cloning algorithm will copy that object, right, into a binary stream, move that binary stream over to the worker thread, it deserializes it back into the objects on the other side, values. Structured cloning algorithm is part of the DOM specification. If you use the structured clone method, it's there. It's part of post message. It's very flexible, right? It supports a lot of different JavaScript values. And using it for abort signal, what that meant for us is that we could create an abort signal on the main node worker thread, okay? Create a new worker thread that says, that's performing some bit of activity. I could create the abort signal in one, clone it, so that when I trigger the abort in one thread, it notifies in the other. Right? It's a pretty useful, bit of functionality. But it was purely experimental. If you look at the spec for abort signal, it doesn't say anything about it being clonable. It was just something you just wanted to try and just see how it worked. And we have some projects based on the Piscina worker thread library that actually make use of this and allow some cross-thread signaling of cancellations. But there was a problem. Abort signal is implemented as a JavaScript class, okay? Which means that it's using that class syntax, right? The other part is that it extends from event target. Now, these two facts are what make this particularly difficult to implement as a clonable object in JavaScript and in V8. First of all, the structured cloning algorithm does not work with JavaScript classes, right? You can give it an object, and it'll clone all of the own properties, the direct properties of that object, right, into the new one. If you have a JavaScript class, like, class abort signal, and you create a new abort signal, and you pass that instance into the structured clone algorithm, you'll get a regular JavaScript object. It will not be an instance of that class, right? None of the properties on that will be there. So, when you have a JavaScript class, you have like the get properties, whatever, that are defined and being defined on the prototype. When you structure clone those, none of those properties get copied over either, right? So it's just, an empty class basically is what you end up getting. So structured cloning algorithm does not work with JavaScript classes, so with abort signal being a JavaScript class, it's not going to work out of the box with that protocol. To make it possible to clone an instance of a JavaScript class, we have to treat it with what we call a host object, all right? And this is a V8 concept. We use V8 under the covers to implement the JavaScript bits. And when we say it's a host object, what that means is we have to implement the logic ourselves in Node to serialize and deserialize that object when it's being transferred, okay? Unfortunately, V8 only allows us to treat C++ objects as host objects. And in Node, we have a whole class of kind of these internal objects that have a JavaScript wrapper object. And then underneath the covers, they're linked to this underlying C++ object under the covers. And that C++ object being connected to the JavaScript is what we can, is what we define as a host object in Node. And we have the ability to selectively, within Node itself, to say, okay, this is a clonable host object, or it's a transferable host object, or it's not, or it can't be used with this algorithm at all. So we can selectively enable that at the C++ level. To make abort signal clonable, we had to link it to a C++ object. Okay? That was problem number one. Node has an internal helper object called JS transferable that allows us to do this. It's not exposed for external users to use at all, but internally, we can use our internal binding to grab an instance of this thing, create this, or have a class extend from this. And by doing so, we make that class, that JavaScript class, transferable. Okay? I already said that. Okay. But it's not quite that simple. Like I said, the class also extends from event target. We don't want to make all event targets clonable. All right? We only wanted to make abort signal, which is an event target. We only wanted to make that one. But JavaScript does not allow multiple inheritance. So we have, our typical pattern is we would create a class and have it extend from JS transferable. Works. But we can't do, abort signal, abort controller. This should say abort signal. We can't make abort signal inherit from both event target and JS transferable. So how are we going to make this actually work? Right? We hacked it. It's a bit of, complex code, just copied directly from Node's source. What this is doing is it takes any object that you pass in, and it's got to be an object. It can't be any other like primitive value or whatever else. It takes that object and makes it transferable, even if it does not extend from JS transferable. Now I'll kind of walk through this in just a bit. If this looks like a big blobby mess, it is a big blobby mess. So it's got a number of things that we use specifically in Node, such as if you see this like object-defined properties, and it's all one. In Node, we actually capture the intrinsic primitive functions. And we capture those up front so they can't be monkey patched later and replaced. It's a whole thing. Makes it really complex. But we take these objects and allow them to be transferable by instead making a JS transferable that extends from the object. So we're inverting the relationship. Okay? So instead of creating abort signal extending from event target, which extends from JS transferable or anything there, right? What we're doing is creating a JS transferable and then setting its prototype to abort signal. All right? And what the object that we actually give to users is not the abort signal directly. It's actually this JS transferable that extends from it. And we can do this dynamically, and that's what that code is doing. We can kind of walk through that if we have time. This is possible using some built-in concepts, reflect construct, object set prototype of, object defined properties. Okay? So here's the process. First, we create the abort signal. Okay? In the process of creating that, it goes and creates its prototype event target. Great. Then we create the separate JS transferable. And then we copy all of the abort signal's property definitions to that JS transferable. And then we set the JS transferable's prototype to abort signal. Let's go back and look at the code real quick. So that's what we're doing here. So we get the object. If it's already a JS transferable, we just return it, done. Right? Then we create this const equals reflect construct. This is, if you're not familiar with this particular function, it will use the first argument. That's kind of the constructor function that is called. The last one is kind of what type of thing you're creating. So it's extremely flexible. You can do all kinds of different things. But basically, what we're doing here is lying. We're saying that we're creating we're giving it the abort signal constructor, but we're creating it as a JS transferable. Actually almost creating one object masquerading as another. But that's not all we have to do. We also like to copy all of the property descriptors from one to the other, right? That kind of allows it to masquerade. Just by creating the object doesn't mean all of the methods and everything copy over. So we're kind of masquerading this thing that we just created, and then we set the actual prototype of that JS transferable to the abort signal. All right? Now, all of this, it's a very magical way of creating slow code. It worked, right? But it is actually very slow. And the reason it is slow is, because of that process. Manipulating or creating the C++ backed objects is slow. Anytime we cross from the JavaScript to the C++ boundary, it's super slow. And this is actually doing that at least once. So creating the object, manipulating the prototype and the properties of existing objects is slow. You're changing the shape of that thing, so it changes the way that V8 can optimize it. There's a number of challenges with that. And we were doing this every time an abort signal was created, which means we were also doing it every time a writable stream was created. And we're also doing it every time a request object is created. So we're adding basically just overhead on top of overhead on top of overhead for an experiment that had absolutely nothing to do with fetch and wasn't even standard, right? So the fix was simple. We just stopped doing it. We just simply made it where abort signal was no longer clonable by default. It's still useful, so there's new APIs in there to make it clonable. Technically, it was a breaking change, but we kind of skirt around that by the fact that this is all experimental code. Right? So we kind of were able to fudge the breaking change a little bit. But just by removing this one little experimental hack, we were able to boost the performance of just fetch in general significantly. And this is just, this is the part I love the most. My son is the one that actually landed the pull request for the fix. And Node is officially a multi-generational project. It's one of the only multi-generational projects. So, super proud about this. So, and that's the moral of the story. Nothing. It was a fun bug to talk about. I love getting up here. I've been writing code professionally for 22 years. I still make egregious bugs. Yeah, it happens. Everyone. It's always going to happen. These are the things I enjoy talking about the most, simply because you learn a lot about the platform. You learn a lot about the process. Seeing the little bit of Node code up here, that little chunk is just like this egregious mess of of sludge to get through. That's a lot of the Node internals. It does make it hard to get into the project. But these are the things that I think really drive a deeper understanding of what Node is doing in the process that we go through. So that was it. Thank you.
It's just a generally good lesson for all open source. Like, everyone's going to write bugs. It happens. It's OK. So just a couple things. We have 3 more talks before we go to lunch. Each talk like 30 minutes. Lunch will be at 1. It'll be upstairs. And after that, we go into workshops. So once we get workshops going, you'll be able to do that. There's a good number of options. So without further ado, take it away, Jean.
Yeah, perfect. Let's just set up everything. Yeah, so here we are talking about, it's a good screen. Heavy computation in Node.js with Rust. So I know we are in a Node conference. Just small reminder, I love Node.js. I do a lot of work with Node.js, but I think there is only 2 lines of Node.js in this talk. So if you like Rust, it's good. If you don't like Rust, sorry, fine. But you will love Rust after that. OK, so another title for this conference and this talk could have been using Node.js, Node API with a hype language for fun and profit. I'm not sure I would have been selected to give this talk with a name like that, but at least you are able to see it. So why fun and profit? Because just basically, we are all writing Node.js API. We are using JavaScript maybe to write front-end application, and that's great. But JavaScript is not a silver bullet which allows you to do everything in the world. You are able to work with IoT, you are able to work with API, compute, to write front-end application, to write pretty much everything, to send, to have some control screen on rocket going to space and stuff like that, which is really great, but it's not the best technology for everything. I'm Jean Burlier. I will be speaking for the next 20-ish minutes about that, and you can find me pretty much everywhere on internet with the name Cheplu, except Twitter. I'm still trying to find, to be able to have my normal nickname, but yes. I'm also working, since the past year, I was working for Allianz, or insurance company, and as a principal engineer, now I'm taking more, let's say, a year off to work with academics and to help new people. I'm really into sharing and mentoring people, so I do spend a lot of time with new students coming into the field in IT and building stuff. Also, I do love to travel, and I'm French, as you can hear. So, yeah, food. And I do have one question. Is there any other French people in the room? Yeah, 1, 2. No, you are not French. So what? Yeah, great. I'm not alone. Okay, so what's the agenda for today? We'll be talking a bit about native code in Node.js, but also the NAPI or Node API revolution or evolution, and let's try to do some demo on Rust with Node Bindgen. First question, has anyone ever used Node API or NaN or native module, native add-on with Node.js? Oh, still a few people, that's great. Great, okay. So for everyone else, add-ons or native module are just basically dynamically linked shared object written in C++. You will use your basic require function in JavaScript, in Node.js, to load every add-on, like every library you are used to load this way. And which is really great is that the add-on part provides an interface between JavaScript and the C and C++ libraries. I'm speaking about C and C++, but it's also mainly every language which can work with that, so with FFI or pretty much everything, and Rust is a perfect candidate for that. For also, one key point is, like you can expect, in JavaScript, we don't really have a lot of type. It's just basically everything is an object. But in C and C++, you can use pretty much a lot of stuff which are not directly compatible to JavaScript and vice versa. So you need to find a way to communicate between both. We do have a bridge, and this bridge is doing mainly the translation between the two worlds, the two technologies, the two languages, to exchange information and be able to communicate together. Which, as you can expect, it's not simple, it's not straightforward, and you can have, let's say, some issue. I will come back to that a bit later, but you can have some issue. And writing native extension requires knowledge also because you need to interface yourself or your code with the C++ part. So you also need to learn about libuv, V8, Node.js internals. So quite a lot of stuff which are not really teach or you use basically on your day-to-day life. And the other part is also if you need to require or to work with some low-level stuff like OpenSSL, or for example, you will need to try to find a way to access it or to find some information about that, which can be quite hard because it's also a bit separated. Yeah, some code, like I told you, not a lot of JavaScript, so definitely not JavaScript code here. It's basically just a module to say hello world using this native add-on. So great code, it's perfect. You can see you do have some V8 namespace, which depend and which has been loaded. That's great. I'm not really a C++ guy. It's been a long time since I haven't just even read some C++. I can understand it, but mainly it's quite hard, and if you want to build a lot of big functions or stuff like that, it will be really hard to, if you are not an expert in this technology, in this language, it will be hard for you. But it works, and you are able to display hello world. That's great. And with a small target with an add-on, you are also able to just provide and build everything else around that, which is great, but because right, always a but. It's really simple, a simple way, and you will still have to work with V8 and mainly low-level stuff if you want to build something which is really powerful. And when it's done and when you build it, so it will be generated in your build or release, something really depend. You just need to load it with a require, and it works. So that's great. This part is not really, it's really easy to use a library. For example, and I will come back to that later, you were maybe using Node.js in the past. Node.js was a native add-on at one time. You also do have some driver like SQLite 3, I think, if I remember right. So yeah, a lot of stuff. And like I said, problems. Problems, 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 every time. Node.js, which is great, is constantly evolving. We bring new feature, new evolution, but you also have V8 implementation, which change every, let's say, too often. And so the interface between V8 and maybe your native add-on will break because some changes happen or people just wanted to update something. So it will just basically break. So it means that every time a new Node.js version, V8 version will be released, you will have issue with your code. You will need to compile everything again, expect that it will work. And if not, you will have to do some changes. That's why on the Node.js part, we did a module, let's say, called NaN, Native Abstraction for Node.js, which at least this time we choose a really good name. It's definitely not a number, so that's great, at least. And mainly, so it's here for since 2015, something like that, so 7 years old. And it provides really a layer of abstraction on top of the Node.js API, which allow you to not handle V8 changes or low-level changes, and you only work with this layer of abstraction, which tend to change a lot less as we try to make it that it doesn't change on every time. And it's basically just a common interface, like if you are a Java developer in the past or something like that, DAO stuff, and you just update what's behind that, and it's hidden for your application most of the time. A small example, if we check the main difference between the previous example and this one, it's really the V8 part, which is not just NaN. You do have some other stuff which change, but basically it's still low-level C, C++. For some expert on this technology, you will be able to understand everything. And yeah, so that's pretty good. But we still have some issue, because it's not perfect. NaN part is not perfect. It's try to keep everything consistent and to allow you to not update everything when it changes, but it's not perfect. So the Node.js people and maintainer and contributor worked on something else called Node API. So the previous name was NAPI, so you will find a lot of documentation called NAPI, and most of the modules which are done by the community are also NAPI or something like that, but it changed like 1 or 2 years ago, something like that, to Node API right now, which, to be honest, it's a really bad name, as when you search online on Google or something like that, just look for Node API, it will be hard to find a good documentation or stuff like that. And one of the main points of this Node API is really we provide a stable ABI, so application binary interface, which define and just export C, type, and function. This way, it's really some kind of middleware between the low-level stuff and your JavaScript stuff. And we try to just have a full abstraction of the JavaScript engine and to allow you to build stuff on top of that, and we guarantee you that we won't break anything. I don't know if some people which were working with an API had some issue. I would love to hear for you if you have some, but yeah. And this work started 6 years ago. Okay, so what do we want with Node API? First, a full compatibility across different major versions of Node.js. So you don't need to upgrade or to do a lot of, basically you don't have to do any work at all when you update from Node 12 to 14 to 16 to 18 to 19, 20, stuff like that. So it should be clean, no change, no update. You don't need to recompile any module at all. Also, it allows you to work with other JavaScript engine than V8, so I'm thinking about Chakra Core and other stuff. It can also help you to work with that. And finally, it's just an API, just a C API, which allows you to implement native add-ons with language other than C and C++, hence Rust. Or some more people are also working with Go. I think I saw a Go abstraction module in the past month that someone was doing that for fun. So that's great. But pretty much you can implement it, and if you want to write some COBOL and API implementation, feel free to work on that. It could be great for banks, insurance, for example. So the main premise behind that is that if it's done right, when you write this kind of module, it's completely hidden for your end user on how, if the module is a JavaScript module or if it's just a C, C++ or Rust module. They will just see it as a basic Node.js module and think it's JavaScript until they go check for it. So in my title, I spoke and I use a Rust keyword. Why Rust? Because I do like to write some Rust. I also really bad in C, C++ nowadays. So basically, let's focus a little bit on Rust. You have three main, let's say, technology or tool written by the community which allow you to easily bind everything with an API and Rust. You have NAPI, RS, NodeBindGen, and Neon, which are the three most used, let's say, technology around that. I think you do have also some other language or other library available on GitHub, but I don't know about the other one. Let's try. So, as I said, I won't write any JavaScript code today. Because, whoop, if I don't lost my screen. Yep. Okay, so, okay, let's. Okay, great. So I don't have anything, any project at all, anything. Let's create. So let's build a new Rust project. Great. I do have a project. Let's open it. And let's zoom for you. Okay. It's maybe a bit too much. So if some people just already know how to use Rust and write some Rust, you basically do have your cargo.toml, which is basically your package.json, and an src folder with a main rs file with a function, a main function saying hello world. Great, perfect. I think it's good for everyone. In my case, now I do want to use and to be able to provide, to build something in Rust to be used as a library, let's say a library or a module to be used by my Node.js later on. So how can I do that? Like I said, I will be using NodeBindGen. It's not the only one technology, but let's use this one because it's the one I'm using most of the time. So let's add it. Let's add NodeBindGen. Well, really bad writing it. Or I can copy paste it. It will be a bit easier. Yep. Let's copy paste the 3 lines that are needed. Okay. So basically, what's these 3 lines are for? First, I require a dependency, NodeBindGen, with a version 5. That's great. Also, for the build dependency, which means when I will build my project, it will use bindgen to do some changes and to do some linked information, which will add some, let's say, feature and being able to build a library and the library being used by JavaScript after that. And the last part is that I just define it will be a library and I will be a C library or C linked library at least. Okay. First step, okay, my package or cargo toml is good. I have every information which is needed to build my project and to do everything. Next step. What do I need? I need to say to my project that I do need to use some custom configuration for the build part. I think, yep, it needs to be outside. So I need to define a build rs file which will give some information to my Rust project when I will try to compile it and build it. What should I do? Basically, just a main function saying that I will use Node.js, and for the build process, I will run an automatic configure, which is a base default configuration information by the project. That's all for this one. And almost the last part is, let's change. I'm building a library, not running it, so I need to redefine. It's not a main file, but it will be a lib, so lib.rs. OK, great. How? Let's say this part is really the setup of everything on your Rust project, and you are now able to start and write some stuff. But one missing stuff is really how to say to my build and to my build and Node.js how to use it, and which function does it need to link to your C++ interface after that. So I will just basically use here on my main function. So I want to use Node.js derive Node.js, great, don't forget that, and no space. It would crash. OK, great. And for my function, let's add that I want to link it and use it with Node.js. OK, great. I think everything's done. If I don't have a demo effect, it should work. Where is my terminal? Here. So now, if I want to just build it with Node.js, you do have a full CLI, ng.cli, and you can just write .build. It will take a few seconds to compile and pretty much do everything, which should almost be over. On massive scale project, it will obviously take more time than just that. But basically, it's doing pretty much everything. Almost the time maybe to take a sip of coffee or tea, but that's all. And no error, which is great. No typo, perfect. And now if I want to use it, if I check just on my here, on my project, it just created a target folder and a this folder with some index.node file because it's what will be used by the Node.js library the Node.js code to use and to run the library. OK, great. How do I use that? Let's open Node. Basically, OK, let's first load it. As I said before, it's basically like just a basic Node.js or JavaScript module, so just require the name of the module, the dist. Yep. OK. And if I want to use it, just use it as a basic module that you will be requiring. So, OK, add the function. I only have one function, which is the main function, and it works. I do have my hello world. Not really a big example, but basically, if you want to do pretty much everything, it's just that way, the configuration. Then you just have to write Rust code doing what you want. Maybe processing images, processing big data set or anything, or pretty much everything. So quite easy and quite fast to do so. Setup is like, what, 5 minutes, something like that, which is pretty good. Also, you do have a lot of performance improvement. I will show that just at the end. But mainly why you want to use Node module, Node native module, add-ons, and API. It's because sometimes you need a better way to compute heavy images, maybe heavy file, because you have to handle megabyte, gigabyte of data, and you want to do it quickly because you want to not spend days doing some compute. So it's really useful if you want to do image and video processing, maybe compression stuff, also everything linked to your CPU heavy task. If you want also to work with math, because as we know, JavaScript is not the best when you want to work with precision number or some math complex operation. So it can be great also to use that for this part. But for me, mainly the main part now is really to just reuse existing code base on your company. So maybe you do have some legacy application which are using mainly C, C++. I don't think you have legacy application in Rust yet. Maybe one day. But now it's mainly C and C++. And it allows you to have a really fast integration because this way you are just able to take your old C, C++ library, bring it to your Node.js project, and with Node API to be able to deploy it on every cloud provider, just on a Docker system, Docker image, and it will work out of the box. This way, no need to rewrite your 20-year-old C++ application for your insurance or bank, and no one knows how it works or anything else. So that's pretty good. This way, you can really expose your core functionality, change, and maybe also kill your old data center / mainframe application, which costs you a lot and no one really want to maintain. So yeah, it's pretty good. Also, another part is maybe you want to use in JavaScript in Node.js some features which are not available by the ecosystem. I'm thinking, for example, maybe TensorFlow. So I know TensorFlow has some JavaScript API, but if you want a core feature, maybe you can use that, or maybe image processing if you want to use FFmpeg. If you want also to use custom driver like GPU, maybe you want to do some, I don't know, heavy compute on your NVIDIA or graphic card or stuff like that. Currently, it's not really possible, even if NVIDIA released a few months back some driver to access directly to your data, to your NVIDIA, or at least NVIDIA graphic card. It's not the best way, so maybe you have a solution which works with that. Okay. Sometime also low-level API, and one thing which is great, it's working also on desktop application. Great. I told you I did have some example like Node SAS, Node Canvas, Node SQLite 3. V8 Profiler, I think, is using that also. Not entirely sure now. Yeah, and we do have a lot of examples on a Node.js project. You can look for that. We will try to also add a lot more example, write article. I think we discussed about that in the last working group meeting. So it's something which is growing, and it would be great if some more people want to be involved. Don't hesitate, just join us doing that. Small tips and feedback about using that. Full disclaimer, I do have just some basic example in production in my old company, not a full scale because of just requirement. But first, Bridge is really costly. You cannot really focus on exchanging a lot of information really fast. So try to just send a bunch of information, handle everything else, and just forward the result at the end. If not, you will lose a lot of time between JavaScript and Rust or pretty much everything every time you cross the bridge. Second one, it's really useful for processing heavy data. Most of the time, I'm around 4x to 5x improvement, so which is pretty good. Also, you do not need to rewrite everything as a native module. Please don't say, let's ditch everything in Node.js, just keep Node.js as a base and rewrite everything in Rust. Could be great, but I'm not sure your company will agree with that. Yeah. But you can try to implement some old stuff or core stuff or part of functionality that you do require more heavy compute part. Also, Rust is really cool, so I love Rust. And I think someone also is talking about WebAssembly tomorrow, so WebAssembly is really good. It's working on the browser and pretty much everywhere, so it's also a good stuff. And just before that, I want just to give you a small example of a basic project. It's really a simple one without any optimization. Up. Okay, so as we know, one of the key solution that is, let's say, heavy compute is just a basic Fibonacci function. So this one is just a basic Fibonacci in Node.js. I think it's going to the 40th item, so it takes 6 seconds, which is great, but could be way better. The same function being written in Rust is way faster, like 1.5 seconds, so 4 times faster. So that's why it's really nice to use it for some compute intensive. If you are doing image processing, stuff like that, it's great. And that's all for me. So yeah, you can find me if you're interested to maybe discuss about it, join and talk to me. I will be in the venue for the next 2 days, so do not hesitate about that. Thank you.
I really love seeing a bunch more Rust in Node and the JavaScript community. It's very nice to see us kind of pairing up together. So one quick announcement. There was a workshop today called Developing a Fully Serverless Application. That's been delayed till a later time. I think it's Wednesday, I'm not sure. But that's been delayed. Instead, Matteo and Rob Palmer will be doing a friendly TypeScript discussion. So yes, we're going to be doing that. I'll be helping moderate that. But if you want to come and join that, or if you were very much looking forward to that serverless one, it seems like it's going to be happening later. Not today,
Wednesday.
but Wednesday, I think. I think it's the last slot on Wednesday. But I'm pretty sure, but I don't want to confirm that yet. But yeah, if you want to come to talk about TypeScript with Matteo, who has, in my opinion, very good opinions about TypeScript, and Rob, who also has very good opinions about TypeScript, join us. I'll leave it to you. Talk about ORMs.
Talking about ORMs. Hi, folks. So, it's so good to be back here at NodeConf and talking about ORMs. I really wanted to do this talk for a very long time. And in order to do it, I actually had to start a company. I don't know. It's very weird. So yeah, follow me on Twitter if you haven't already. But if you haven't already, probably you want to. You're not here, so I don't know. Anyway, yay. So at Matteo Collina, you probably know me. If not, subscribe to. Oh, sorry, it was not supposed to happen. Cool, funny. Okay, demo gods. Okay, the demo gods. Now I understand what's going on. What's happening? Okay, Nodeland.dev. Here we go. I don't know. Follow me. Anyway, I'm the CTO of Platformatic. You can find a box of T-shirts down there. We are a young company, just a few months old, and we didn't have the time to do a full booth, but we have a box of T-shirts. So if you want to grab one, come and grab one. So anyway, let's talk about object relational mapping. How many of you is using ORM? Okay. I think the other half is still using an ORM. I don't know. It's just one of those questions. Anyway, what does this do? This maps relational databases to objects. Okay, so you can actually have fancy objects that maps to your databases. Is this good? Is it bad? Is it just neutral? I don't know. I'm not a fan. So okay. So when ORMs were introduced, they actually started promising a rainbow land with unicorns and rainbows. Okay, I don't have a fancy slide like Cody, but I have a bunch of spaghetti, just like that. So basically, they're all neat, okay? And they were presented like, oh, this is going to become very neat and straight. Everything will be very organized, and we're going to use a lot of models to develop our application. It's good, right? And then we will have relations between those models. So we can actually navigate our code base just by using those relations. Oh, so nice, so neat. This is a brilliant idea. It's brilliant. Okay. Do you know what happens when your application uses an ORM? It hibernates. And if you're getting this joke, you're not having coded enough Java in your life. Okay. And yeah. And by the way, the image was done by DALL-E, so it's just so. Anyway, what's the problem with ORMs and the concept of models? Okay, models typically work like that. So you extend them, and then you have like their save and delete and those type of function that sits on the model itself. And then you also put business logic in there. Typically, you do a like, and you do all those nice things. It's cool, right? It's all contained. Like I put the logic of handling my database and the business logic in the same place. Now, the problem is that this does not work great. This does not work great. Okay. Once you have 1,000 of them, you are in trouble, because you don't know what's going to happen in your code anymore. It's really, really, really difficult to untangle a large code base that is built upon the concept of models. In fact, you probably have used a few model view controller systems in your life. where you have a models folder. How many of you have a models folder in your code? Okay, I'm talking to you. You might have 2,000 modules, 2,000 models in your application very soon, so probably not easy. When you're building an MVC app, and this is the problem with all MVC app systems, you have a model view and controller, and whenever you need to add a new feature, it's either a model, a view, or a controller. And the problem is that most of the time, we are not doing views anymore. So we even have a controller or a model. Ouch. But we don't do controllers in Node. We just use routes and so on. So we just have models. And basically becomes, well, some big block of spaghetti code. Okay? And by the way, I love carbonara. I really love carbonara. Okay? So just to clarify. So talk about Fastify. Why does it matter? Why is it going to Fastify? We're talking about ORMs. Yeah. Well, if you're doing an MVC system, you might want to do something slightly different than MVC, because MVC, how can I structure my code to grow long term if I only have 3 buckets to put my stuff in? But with Fastify, but also other stuff, I can actually structure it by features, not by system, by features, not really by what table in my database I'm sticking my stuff on. So, okay, so this is slightly better. Help organize the code, but also it can help it's actually the starting step for going multiple processes and doing microservices, which is also pretty fun. And again, we are doing working off coding the large type of thing. Okay, so we are going back to our old friend Pareto and the 80-20, which is a nice picture, by the way. And with Pareto, you have a very fancy thing where 80%, like only 20% of the causes leads to 80% of the outcomes, which in practice means that if we need to develop some code, only 20% is at the end. It responds to 80% of the effort, which is pretty bad. So you're picking a framework and you're picking a technology, okay? And whenever you're picking that technology, okay, what would you optimize for? Okay, what stack, what things would you optimize for? Would you optimize for something that's go at the start of the project, something that is very easy to get you started with, that has a good generator, a good tutorial or whatever, or something that is very good for developing complex features? Okay, what would you choose? Look, you can choose something that's good for doing repetitive tasks or something that's good to maximum flexibility. Those are the two brackets. So ORMs typically do something very funny, because the ORMs simplify at the beginning, okay? They simplify writing models, they simplify things. However, at the end of the journey, you're still having to write some, 10% of code that is very custom, very specific. You need to write some very hard SQL by hand that's not easy to maintain or anything. And you're actually fighting against your ORM because you have the types and everything it's not working, okay? So, what can we do, okay? Note that we are also, if you're using an ORM, you're also exposing your models as routes. Okay, so you're doing some work here and so on. Cool. What can we do? Okay. Well, I claim that the best line of code is the one I don't have to type or maintain, mostly maintain. I have a lot of open source, $12 billion per year. So best line of code, the one that I don't have to maintain, myself at least. Might be somebody else's problem. Anyway. So I'm a backend engineer, and when I'm picking up a backend, I really want something that can be run locally, and it's something that can be, can be extended very easily. You could use SQL, you could use code, you can actually put a lot of custom stuff in. I built a freaking framework on the concept of extensibility of plugins, right? So I want something that provides a basic some basic level of authorization baked in. Authorization is one of those things that takes a lot of time to do it. Very few people know how to do it right. Most people will make a mess, myself included, and you don't want to repeat it to repeat it again. So something that gives me the basic done, that I don't need to think too much about it and trust what's done. It's very important. I want GraphQL, but I also want REST and OpenAPI. I love REST. Okay, I also love GraphQL. Why fight? Use what's best for you. Then you could use Apollo Federation because you want to federate your GraphQL schemas. And I want also something that actually can deploy them on my cloud, on servers that I maintain. It's not something like, what's the fancy term? Cloud Prem. This is fancy, it's a buzzword, okay? And I want something that just runs multiple databases, not something fancy that can only run on the cloud or whatever. I just want something that can run on multiple databases and don't worry about it. Okay. Mostly, I also want all of this, and I don't want to write it when I need to write a new application. Like I'm building a new startup, so we are probably having some database somewhere at some point in the cloud. And we didn't want to do all of this from scratch again, right? So, you like cakes, I presume. If you don't, I'm sorry. There's a lot of sugar in these slides, so if that hurts you, cover your eyes. Anyway, I want to have the cake, okay? But also eat the cake. Because, you can even add the cake or eat it too, but I want both. I want to have a backend that is super flexible, super extensible, but it also absolutely spend no time writing it. Ouch. How can we make it happen? How can I make it happen? So, yeah. Okay, so that's what we are doing at Platformatic. Okay, the first open source tool that we have that we have released is a thing called Platformatic DB. And it's something that can help you do all the repetitive tasks, but also enable maximum flexibility for your code. We have a bunch of docs, okay? At oss.platformatic.dev, you can check out all our docs. It's very nice docs. It's built on Docusaurus 2. There's a fancy stack down there, so you can also check out the website is built. And by the way, this was never private. It was open source all the time, but nobody was looking. So, yeah. Anyway, how does Platformatic DB work, and how Platformatic how we envision development? So with Platformatic DB over here, the developers typically write their own schema, the migrations, you apply them, then you set Platformatic DB up. And then, whenever you're needed, sometime later, you can just write your custom code. There is nothing else that you need to do to get up and running with some basic CRUD functionality. You can just write your custom SQL, write your custom code. And why do you say you stress so much about writing the custom SQL? Well, you have amazing databases that you're all using. When you're using an ORM, they need to go to the minimum level of features between all of them to provide a common API. And you're not using all the power of your database. Postgres has shipped all the JSON amazing things that you can query with. And for years, that was not available to people using ORMs. Same goes for MariaDB and my latest version of MariaDB and MySQL. Or, you might just want to use good old MySQL 5.7, which is still there and hanging around and not dying, okay? Anyway, how does this work? Basically, it's all based around Fastify, and you can just, there is a command line tool, and when it starts, we can just load your plugin. Just works, okay? It's great. So now, it's a little bit time to make our prayer to the demo gods. And let's hope everything works, because you see, I was fixing my demo on the other side of this wall like half an hour ago. So let's hope everything is fine, okay? So, this one. Okay, NodeConf. And Siri is very happy. And NodeConf directory is free, so I just need a little bit of a package JSON, so I'm just creating my package JSON easily. Okay. After that, what we're going to do, we have Platformatic. Okay. npm I Platformatic. Matic-G, and we are going to install it. Okay, it's downloading from npm, so we'll see if the network is working fine. As you see, it's all live. Okay, so I'm not completely not complaining about this stuff. So here we go. Takes a bit of time. Do you know that npm is low, right? It's downloading 600 modules now, so, and compiling some. You will see the tree and so on and so forth, okay? Takes a bit. We also have a Docker image if you want to play with it, with just downloading 200 megabytes in one block. So you pick your poison. Anyway, 453 packages. So we have Platformatic, okay? And now we can get the version, and it's version 0.1, okay? Remember this. It's the one that we released a week ago. Okay, so in order to start, we can do Platformatic as a few commands. You can see Platformatic help. So we have help and db, but there will be more tools coming, so tune in. We can init our project by just running Platformatic db init. After we have run Platformatic db init, it complains that we need to install some dependencies. Why? Well, because we want auto-completion. So if you want auto-completion, you might want to run to get those things installed. So what we do is we'll just copy this up, and I am going to install the things, all the things, okay? So, and here we go. This is installing. Oh, interesting. This crashed. Oh, I am. Yeah, I am. I do am. Ah. Yeah. Just a second. Yeah. I did mess it up. Thank God. cd NodeConf. Okay. So, okay. Here we go. We are installing this. Good. And then Platformatic init. Yeah, Platformatic db init to get it done. Okay. Now, what it has created for us? This has created a few things for us. It has created a new migration for the movies table. Do you like movies? Yeah, okay. So we're going to do some movie stuff, okay? So how do we use this? We run it with Platformatic db migrate. So we run our migrations, okay? The system has always also created us a file called plugin.js so that we will extend our Platformatic database later. So now we can actually open this up and look at our Platformatic db.json, which includes some interesting configuration from the types to the connection strings and so on and so forth. So what we do now, we can do Platformatic db, and this automatically starts. And we can open this up. Cool, welcome to Platformatic db. Okay, we have something here. Let's just zoom in. And it's now what we can do, we can go to graphical. Do you like graphical? Yay! You should like, oh, it's fancy. The power of the internet. It's downloading it from Unpackage now, and it's taking some time. I should have this open already. Okay, before going to graphical, because it's loading up, and I can show you the Swagger UI. So the other feature that is that we provide is fully and complete open API generation and the routes. So okay, and graphical also came online. Good. So can you see this? Hopefully. Yeah. Why it's not? Sorry. Okay. So what we can do now is, for example, we can do a mutation. And in our mutation, we can do save movie. And input, what movie do we want to save? Oh, I want to say Harry Potter. I want to save Harry Potter. Do you like Harry Potter? Hopefully so. I like Harry Potter. ed and title. Okay, so now we can run this. And we see it's saved. Okay? Let's do a quick check with our Swagger. And let's run from the get movies, okay? Which you see there is a lot of properties here that we are not going to look at. But what we can do is try it out. So if we want to try movies, we can actually execute our query. And you can see that it has executing a command that has resulted in this output, which is Harry Potter. So it's all completely working both ways. So back to graphical, okay? And in here, so what can we do with this movie? Well, we can do quite a few things. So this is Harry Potter. And now we can do a query. And we might want to say movies and the D and title and run this and I need to add the name movies and I can just run this and it works the exact same. Okay, I can also specify a lot of things here, like for example the where clause, and I can say that its title is equal to if I put Star Wars, and it's not, I made a mistake. I need to say it's equal to Star Wars, and it's not movies. It's not showing anything, okay? So it has full filtering capability and so on and so forth. It doesn't provide all the capability of SQL, but it does provide a bit, okay? Why? If you want more, just use SQL and just extend it. We'll see that in a moment, how to do that. Cool. So, but this is not enough, okay? Because we are missing one of the key capabilities of SQL database, which are relations. So let's add one. So what we need to do is, this is running, by the way, okay? So I need to open up my migrations, okay? And creating another one called 002.do.sql, and I can say create table quotes, and I'm going to open up, and yeah, I don't need this. I need ID, which is an integer. We are using SQLite to the demo, so, and it's an integer, and then we need a text, which is a quote, and then we need the movie ID, which is an internet, but it's reference movies ID. And because I'm cheating, where is it? CD4, okay, cat. Going to double check because demo movies, migrations 002, because I don't want mistakes. Okay, so I need primary key. Okay, integer not null. Okay, so integer primary key. Here we go, primary key. Okay, and integer not null. Cool. Okay, and we need to this. I can just save. Okay, and if I go back here, you see that it has automatically run our migration and reloaded everything. So I'm not touching this. I'm just going to refresh my graphical. And now what I can do is I can add a mutation, add quote, and do save. I need to reload. Save. Oh, save movie. Ha, it didn't pick it up. Cool. Yay. Very funny. What mistake did I make? The demo gods didn't pick it up. I'm going to restart it now. Haha. Made a mistake? Haha, you see the demo gods. Yeah, no. I did make some mistake. I'm pretty sure I did. So create table quotes. It's not there. Big time. Funny. You see? Let's do this. Oh, where I am. Platformatic db migrate. Why is not picking it up? Haha. Okay, now it picked it up. Not sure where it was when I was running those commands. So platformatic db migrate, then by db start. Okay, now it's there. Cool, okay. Sorry for this, I don't know what happened. Okay, now we have quotes. Cool. And in here, what we can do is we can save our quote, okay, and we want our input field, and we want the movie ID, and we want to specify it. Oh, I need to save, first we need to save it. Okay, so I just need to copy this up. I need to save Harry Potter again because I flushed the database. So I'm adding Harry Potter, cool. Then I'm putting ID 1, okay? And then I want the quote. I am up to no good. Good. And then we can say that we want the ID and the quote and the movie and the title of the movie. Let's see if all of this is working. And add quote. Oh, cool. It's actually navigating the graph, okay? So we can actually extend our movies here and just add the quotes for those movies and the quote text. And now I can run that, and it's still working as I would expect. Note that we can also have the full Swagger UI capability to navigate and do all the stuff. Cool, okay. So, however, it's what do? You want to add stuff to it, okay? You typically want to, okay, so, fine. You typically want to to add some more features and to our application, okay? So in order to do that, we need to we have our plugin.js file, which was automatically generated for us, with some TypeScript fancy things in there. What do they do? Okay, so what you can do here, for example, is console log app await, while this application starts, await platformatic, okay? And we have entities, and we have movie, okay? And then we have find, and we can, just run it and save. And you can see that we have printed Harry Potter on the other window. It's not reloading the process, by the way. It's all done by the same process running. It's pretty magical. So what we can do with this, it's, for example, we can say that we can add a titles route, and we can get this and make our and return an array of titles because we just want a route called titles. Cool, right? So I can just save this. I can open up a new terminal, and I can just go to titles, and it's just working as expected. Okay, I have not reloaded my system, by the way. So now I can even do something interesting. I can do app GraphQL extend schema, and I can just say that I want to extend type query, and I want the titles, and the titles is just a string. And then I need to app GraphQL define resolvers, and I need to do query, and I want titles. Oh, yeah, great. And then I can do return the same thing as I was doing before. And now, let's see if the demo gods are with me. The demo gods are always, funny. And we can do query and titles. And here we go, titles. And I can't get it didn't reload. Gosh. Did I make some mistake? Titles? Let's see. Oh, yeah, you see it's complaining. I should get it hooked up with the notification for the demos. So it's typo capital S. Cool. So now it says that it's reloaded correctly. Okay, so now I can actually reload this. Ouch. Yeah, sorry. Service unavailable, funny enough. Okay, so now I can say titles, and I can say titles, okay, it's working as expected, and I can actually run it. Oh, cannot present value. Oh, yes, of course I can't, because this is wrong. So instead, I need to do it. I get an error because this is not what I need. So this is movies. It's not titles. So I need to return movies.map and m.title. Cool. Now maybe it's working. Would you work? Okay, it's working. So it automatically reloads, okay, most of the time. It's minus bugs. And so, cool, yeah. But you know that later on we have a TypeScript panel, right? So what about TypeScript? Like I have types, but can I write my plugin in TypeScript? Well, you know what? Do you know what this is? It's a YubiKey. Why do I need a YubiKey on stage? Okay. I'm plugging my YubiKey in, and I'm going to my Platformatic local copy, and I'm going to release the TypeScript support. So in order to do that, I'm just, my setup is very vanilla, so I'm just bumping the major version on the module. Then I'm doing scripts and sync version, which has done what you think it's doing. Then I'm doing pm-r publish --OTP, which this is why I need the YubiKey, and this little utility to get my OTP from the YubiKey, so that's very fancy. And oh yeah, I need to commit. I love this. I'm mine on n, my sas. Look, I'm doing it live, as I said. Okay, so I'm pushing. It's pushed. It's publishing. So it's taking a bit of time. On my computer is actually a little bit faster because it's almost instantaneous, but it's doing its job. And here we go. And one is up, the other one is up. We're going to do a demo with all of this tomorrow afternoon. So if you're willing to check it out and doing a little bit of movies and quotes together, we're having some fun, okay? And here we go. Takes some time. Hopefully the OTP token is not going to exhaust itself. Let's see. Things can go wrong. On my machine, it's always like that. Okay, we are getting through. Cool. So while we are doing this, and I'm going to demo TypeScript in a second, okay, I just want to go a little bit more on the slides. Okay, so where did I put this? Cool. So how is it possible? How does it work? Platformatic DB is just a Fastify application which has some modules inside. So we have SQL Mapper, which provides us that utility to get the entities and do some very simple queries. We have a SQL GraphQL model and a SQL OpenAPI module to actually do SQL, translate the mapping to GraphQL and OpenAPI. And you can add your routes and resolvers. So if you want to write something complex business logic, you could just use your routes and resolvers. But if you want some CRUD and get up to speed very quickly, it's just there. Oh, by the way, we also support authorization. So that's a different talk. So, but check it out. It's all in the docs. Something very interesting, though, is that you can even take it the completely opposite step and just use our modules. Because they are modules on NPM, so you can just use @platformatic/SQL Mapper and @platformatic/SQL GraphQL on your own application, on your own Fastify application, just to reduce some of the work. and speed it up your normal development. No need for any fancy stuff. You lose the fancy library load thing, that almost works, but the rest is over there. Last but not least, did I just code an ORM? For you to decide, okay? And before this, let's go and talk about TypeScript, okay? Yeah, you see, the OTP exhausted itself. So here we go, authorization, authenticator, and it's, here we go, where is NPM? Here we go, okay, command passed. Here we go. Cool. Here we go. It's up, and we have Platformatic 0.2 published on the network. So now we could do is cd, make dir NodeConf 2, and npmi Platformatic -g, and just update it, because we just released it, so I'm just updating the thing, okay? And after this, we can actually run it with TypeScript. Let's see if it works, hopefully. The demo gods are with me. Still have time, right? I was supposed to take a little bit, 5 minutes longer or something, so I'm filling in time. So, good. So we have Platformatic installed, okay. So now we can verify everything is there, Platformatic-v 0.2.0, hooray. Okay, so now I can do NodeConf 2, and then I can do Platformatic db init -- types, TypeScript, and yay, we got something very interesting in. So I need a package JSON to add my modules and install some stuff that's are needed, some dependencies to add the types. Then we can do Platformatic db migrate. Oh, sorry, migrate. Cool. Then we have a plugin.js file, plugin.ts file. Whoa, it's a TypeScript file. And now what we can do in here, can do Platformatic entities and movie, and everything is working as well as you would expect. How it works? There is a types folder that's automatically created for you that will create all the types for your app automatically. And it's just very simple types, by the way. They're not anything fancy, but it's good enough for most use cases. So having said that, and having demoed something like TypeScript on stage, which is something that I would never thought I would do, you know, it's. I just wanted to thank you for coming, okay? And I just let you ask you to go to platformatic.dev. Maybe we also have a Discord community and everything. So please sign up, and we'll notify you. We don't spam you, but please sign up if there is, so we can let you know about some of the new stuff we will be building and releasing soon. And thank you for having me today.
There was one part there where you said you did this all in the open originally. So is there more stuff in the open that we can go see?
Not yet.
Okay, so we should just always continue looking and
there will be
see the announcements before they happen.
There will be some more stuff. There is some. We have more features that I haven't demoed today, and there will be more tools coming in the next few weeks, months, years, decades, centuries, whatever. So.
Cool.
Bye.
Thank you, Matteo. So just another quick thing on a topic I talked about earlier. As I said, we're going to what was the bar called? Billy Burns. We're going to Billy Burns later. There's going to be 2 buses that take us. If you haven't signed up already, you either should have an email or you could, so there's an email with a link that lets you sign up and say like, hey, I want to go, express your interest. If you don't have that email, feel free to DM the Twitter account, so NodeConf EU on Twitter, and they'll send you the link. It just helps us get a gauge of how many people, and like, if 200 people want to go and we have 2 buses for 160, that's like rough. So yeah, if you are interested, either DM the Twitter account or go check your email and register through that. That'd be super helpful in just making sure we have accurate numbers. Yeah, so with that, I'll let Mikola go. You good? Almost. Almost? Okay, cool. Perfect. Good.
All right. Okay. Welcome everyone to my talk, Lyra, Disrupting Full Text Search Industry with JavaScript. It's quite of a strong claim, I know. We will see if we can get hopefully there. So before we start, let me introduce myself very, very quickly. Let me see if this is working. Yes, OK. So I'm Michele. I'm from Milan, in Italy. I work as a senior architect at Nearform. I'm a Google developer expert and a Microsoft MVP. And when I talk about full-text search engines, I always want to start praising the god of full-text search engines out there, Elasticsearch. So believe me when I say that Elastic has been the project that got me into open source. I love it. I had the opportunity in my career to work with the Solar, with Lucene directly, but Elasticsearch, it's just on another level. I love it so much. I had an opportunity in the past to work a bit on Apache Unomi, contributing to that project. And Apache Unomi, it's a customer data platform, and it's an open source project, of course, that uses Elasticsearch as a leader database in its architecture. And OK, I was pretty junior at the time, but when I saw millions and millions of data coming through every week, I was like, how is that possible, right? How can a software handle that much data? That's incredible, and still be performant. So it doesn't matter if you have like 1 million records, 1 billion records. Elasticsearch, it's always performant. So how? How does it do that? If you're not into Elasticsearch, just for you to know that basically it uses Apache Lucene, just like Solar, but provides a nice of good features on top of it. So Lucene, it's the actual full-text search library that performs the search operations, but Elasticsearch does a lot on top of it. So it's a RESTful server, so you don't have to code Java, which for me was super good. It's a distributed system, which basically allows you to scale horizontally your cluster, adding more and more data without losing any performance. It auto-manages sharding for you. It takes care of data consistency, monitoring, cluster management. It's awesome. So before proceeding any further, let me be super clear from the beginning. I love Elasticsearch. And yes, I am talking about something that I built, that it's hopefully competing, but I did that because I wanted to learn more about how is it possible to have such a good product, not because I didn't like it. I want this to be very clear from the start. And also, I don't have a computer science degree, and that's the only way I can learn stuff. So what I cannot create, I do not understand. And I'm quoting Richard Feynman here. I need to build stuff to understand how things work. So remember, I love Elastic, but still I had some problems with it. It's quite hard to set up and deploy. It's hard to upgrade, so if you have like a security patch to be deployed, released, it's not the easiest thing you're gonna do, and has a big memory footprint. So if you couple that with high CPU consumption, it is very, very expensive. So if you're running your own cluster on AWS, Google Cloud Platform, whatever, it's gonna be very costly. And if you're using the cloud version, of course, it's also costly because someone has to compute that data, right? And maybe I was too inexpert, and Elasticsearch was a bit too much for me. I know that making simple software is hard, but it's worth trying it. So I set myself a goal. I had the unique opportunity to speak at We Are Developers in Berlin this year. It's the biggest developers conference out there. It's 8,000 developers coming from all over the world. And I set a goal. I want to give a talk on full text search algorithms, data structures. I mean, I want to explain to people how it works. So that was my goal. I can work in two modes. With goals, by building stuff. That's all I need. And a bit of luck, I guess, because when I started looking down and going down the rabbit hole with the theory behind full-text search, I mean, it's not an easy thing. And that's why we all love Algolia, Elastic, Mail Search, etc. All beautiful products. But I definitely wanted to learn more. Also, the hard truth. You need to study algorithms and data structures if you want your code to be that performant. We will get there later on. And again, not having a computer science degree myself, I don't have like a place in my mind where I can go and see, oh, maybe I studied this algorithm, maybe I seen my professor. No, I had to actually start searching for stuff. And also, when you start understanding how things work, you need to choose a programming language to implement your algorithms, your data structures. And of course, I wanted to be a cool guy, so what, Haskell? No, cool kids don't use Haskell. I wanted to use a cool guy. So I started implementing with Rust. Too complex, no way. I have no idea how. I've been programming Haskell for a bit, so I thought, okay, Rust might be easier, right? No, it's not. But it's super cool, and I'm definitely the problem here. I also started refactoring everything in Golang. Same problem. I spent my life writing TypeScript and JavaScript, basically. So I remembered a famous quote from Jeff Atwood, also called the Atwood Law. He's the co-founder of Stack Overflow, that says, any application that can be written in JavaScript will eventually be written in JavaScript. So why not? JavaScript is the king of programming languages, right? Yes. I guess. So yeah, and that actually led me to something that I wasn't expecting. When I started implementing the data structures required for implementing full-text search, such as trees, hash maps, inverted indexes, etc., I made a comparison with Rust and Golang, which, okay, maybe weren't so well optimized, of course, but I started thinking that there is no slow programming languages, but just bad algorithms and data structure design. So that's the first thing I want you to bring home. This is an essential part of our job. And when I started making benchmarks, when I gave my talk, people seemed to be impressed with the speed, and we will see benchmarks later on. So eventually, my team at Nearform decided to open source this, so we released Lyra, which is a very nice name, especially if you're here in Lyra. I don't know how to pronounce, but by the way, it is nowadays an open source project, so whatever you're gonna see from now on, there's no premium features, there's nothing, it's all open source. And it's maintained also by a good community. A good community has born around it because we decided to code everything from scratch. And we decided to do that without any dependency for a very specific reason. When we started looking at other alternatives such as Minisearch, Fuse, Lunar, which are full-text search engines built in JavaScript, which are exceptional. Don't get me wrong, they are very good. We wanted to do something a bit different. We wanted our search engine to run literally everywhere. So we had to implement everything from scratch, starting from the prefix trees, the inverted indexes, B trees, tree maps, the stemming algorithms, and we will get there after, stop words, and support multiple languages such as Italian, English, I don't know, German, whatever. And eventually, we did it. So nowadays, Lyra is working on every single JavaScript runtime. All the runtimes you see there, plus Graal VM. Is there anyone knowing Graal VM? I'm sorry for you guys. Yeah, but Rhino, if you really want to get fun, you know, wherever JavaScript runs, Lyra runs. It's all made in pure JavaScript, no dependencies at all. But that also opens to a world of possibilities, you know? Lyra works in browsers, on BAN, on Dino, React Native, Node, Lambda functions, and Netlify functions and Cloudflare workers, which are exceptional platforms, which gave us a couple of problems. In fact, I was in Berlin again, and I met an engineer that told me, you know what, it would be cool if you could run full-text search on the edge on Cloudflare workers or Netlify functions. It was very hard, but I had, you know, thankfully, I worked with Paolo, who is going to give a talk on Wednesday. And we were in the hotel hall together, and I said, how can we make it run at the edge? Michele, hold my beer. That's all he said. And we made it. So I'm going to showcase later, but we basically created very tree-shakeable and a very tree-shakeable and tiny full-text search engine. And let me give you an example of how it works. So you basically want to create a new variable and you create a new database. You insert a schema. So it's not really schema-less like Elasticsearch, for example. Still, you have to define your schema and your types for your data, which really helps us in creating the index. When you're going to deploy it, you can bundle it. For example, if you deploy it on Cloudflare workers, you might not need the insert function or the create function. You just want to perform search. So you just import search, and it's tree shakeable. You only get your bundle with the search function. In fact, the DB variable in that case, it's nothing more than a JavaScript object. That was a bit surprising to me because JavaScript object, every time you modify the shape of the object, gets slower. That's what I thought. So that's why at first we started implementing with maps, with sets, which are known to be faster, than maps. But eventually we discovered that for our specific use case, objects and arrays were just perfect. So that's another discovery I made. There are cases, most of the times, where new JavaScript features such as maps, weak maps, or sets are faster in many cases. There are cases where the standard JavaScript is just fine. So always measure your performances. Then you can insert data, and this is blocking the event loop, by the way, but we export an asynchronous function which is called the insert batch. So you basically, as you can see, as a first argument, you pass the DB, so you actually mutate the original database by inserting new data. And then you perform search. In that case, we get the database. We perform search for the term if on all the properties. Eventually, you can also say, OK, not on all the properties, just on, let's say, quote. So I pass an array, including just the properties I want to perform my query on. And the elapsed property that you see here, 99, can you guess what is it? Seconds, milliseconds? What? Sorry? Minutes, yes. Hours, days. No, it's actually microseconds. I wish it was minutes, but no, it's actually microseconds. So we are in the millionth of a second area. And you might say, yes, but you inserted just for 4 documents. So of course it's fast. For that reason, on my machine, on M1 Pro MacBook, I did a benchmark. And for example, I took whatever I could find on the International Movie Database, so titles, quotes, descriptions, cast, whatever. I put it into Lyra, and I said, OK, let's search believe through 1 million entries. And it took just 41 microseconds. Again, we are in the millionth of a second area here. So then I said, OK, maybe I can try just on the title property, 39 microseconds, which is almost the same. Then I tried with Criminal Minds. I'm a big fan of the show. With Criminal Minds, full-text search engines have to perform 2 distinct queries. Have to perform a query on criminal, a query on minds, then look into a forward index to see if minds is happening after criminal and give it more priority, etc. So there's a bunch of stuff to do, and it takes just 187 microseconds again. So it's really, really performant, if you ask me. And nowadays, it supports 23 languages. So if you, like me, don't know nothing about Dutch, for example, I wish I did, but I know nothing about Dutch, you don't have to perform stemming operations on Dutch. So when I talk, or Italian, I'm Italian, I could do that, but the stemming algorithms are not that easy, and I'm getting there in one moment. So basically, when we talk about stemming, for example, we refer to that process to take the stem of an individual token. For example, we have lucky. We stem it to luck. So we actually insert the meaning of the word rather than the entire word. Of course, if someone puts like lucky, we could store both. So you can have like exact match search or whatever, but that's another story. And with Lyra, you can always extend whatever you want. So you can, given that Lyra basically provides you a series of indexes, you can create your own searching algorithm if you want. You can create your own stemmer, and we will get there. How do I create a stemmer? Well, if you're into natural language processing, for example, I would recommend you looking into Snowball. Snowball, it's an open source project created by Martin Porter, which is the author of the Porter stemmer. Sorry, which is nothing more than an algorithm, a step-by-step algorithm description that if you follow it, will help you creating stems from words. For example, search for the longest amongst the suffixes. So if our word ends with S, we just remove it. If our word ends with SSES, we perform that operation. So, step by step, we can create it, and you can have a lot of fun. It's super difficult if you ask me, but it's definitely very funny. And just for giving you an example, we have like consign, which gets stamped to consign again. Then we have consigned, the past form, which, again, we keep the meaning, consign. So this is what Lyra is doing for you every single time you insert a new token. And again, you can do it in Italian, we support German, we support 23 languages. Or you create just your stemming function. The goal for Lyra is to empower people to learn more about these algorithms. So you can, for example, give an ish suffix to all of your words. So if you put like hello, it becomes hello-ish, whatever, why not? You can do it. You can also customize stop words. Whatever the processes that Lyra is running, you can always customize that. So the project goals for Lyra were to work on any JavaScript runtimes, and we did it. To be as small as possible, as fast as possible, and easy to deploy and maintain, because that was my original problem with Elastic, So the achievements for Lyra, okay, it works on every JavaScript runtime. It's small and modular. It's quite fast, if you ask me. Can be deployed literally wherever JavaScript runs. And you can also serialize data in different formats, and has a powerful plugin system. So let me give you an example of a plugin. You might want to persist your data on disk at a certain point, so you just install Lyra Search, plug in data persistence. You create your instance. So original instance, in that case, you put a couple of quotes and authors. Then use the persist to file function, which is runtime specific, that works on BAN and Node.js specifically. And you just choose the format. By default, it uses message pack, which is a serialization format also used by Redis, for example. So you can use message pack by default, DPack, JSON, protocol buffers. You can do whatever you want, basically. And after you did that on another file, as you can see, I'm not like Matteo. I'm not doing live demos. I'm not at that level yet. But you can restore data from disk and start performing searches. So now that we know what Lyra is, I want to give you a couple of target architectures. For example, let's say that you have a React Native application. You have a Lyra server, which performs search, actually, and you have your application. You can continue pulling from the server, and when the connection is down, you can say, OK, I will fall back to the local database, which might be like a SQLite or an in-memory database or whatever. Or, and this is more interesting for me, you can create a very distributed, doesn't make sense, but a highly distributed system by deploying your Lyra indexes serialized on S3. You can notify SNS, for example, which rebuilds some lambdas, performs some optimizations, and makes it available, the new index, to CloudFront, so that after you query something, you have a lambda running on the edge performing the searches for you and caching everything. So you treat Lyra as an immutable database, and if you need to update, remove, do stuff on the index, you just do it as a batch operation every 5 minutes, every minute, whatever. So you can't forget about cluster management, deployment, data consistency. AWS takes care of cluster management when it comes to Lambda functions, for example. Deployment, we will see in a moment. Data consistency, we'll see again. You can deploy to anywhere using Nebula, which is still experimental, but I have, again, I'm not doing a live demo, but I have a recording from my friend Paolo deploying Pokédex to Cloudflare workers, for example. So let's see if we have internet connections. So first thing we do, we look at the, we basically install the Nebula package, which is a global NPM package. We just use Nebula. And yeah, Lyra is named after the Lyra constellation, and nebulas are where stars get born, and etc. Yeah, that's crazy. OK, so if we look at the files we basically have a data.json file, which represents the data we want to deploy to Cloudflare, for example, and lyra.yaml. If we go see the lyra.yaml file, it basically has a schema, which is a schema definition for our data. Sharding, auto, true, false, it's not working yet, so just don't use it. We will give support as soon as possible. An output file, so we can decide wherever we want to deploy to Cloudflare, which we are going to do, or keep a copy of your data locally. Then the data we actually want to deploy, in that case, type JSON, because we are taking the data from a JSON file, and the JSON file itself. But we could also say, OK, the type is JavaScript, so we use a JavaScript file exporting an asynchronous function so that you can call a database, for example, and take asynchronous data and feed Lyra and then deploy it. Again, target, in that case, it's Cloudflare, could be Netlify, could be AWS, whatever. Configurations, worker name, Pokédex, why not? And if you want to run tests, true or false. If we go ahead the JSON data, we will see that basically we already created a JSON file with the same schema as the schema definition for Lyra. So we are ready. Let's clear everything and run Nebula D, which stands for deploy, of course. And in just like 5 seconds, you just deployed a Cloudflare worker. So as you can see at Pokédex, which is the name we gave, Paolo, thank you again for doing that, which is your Cloudflare account, for example, .workers.dev. And if you use CURL, you just run queries on Cloudflare. So congratulations, you just deployed the first full-text search engine capable of running at the edge. So, I don't know where is my mouse. Oh, here it is, OK. So as I was saying, Lyra, it's free and open source. You just go to GitHub, Lyra search at Lyra. Please open issues. Please ask for stuff. Please do whatever you need to get start working with Lyra. I'll be there to help you, guide you through target architectures or, I don't know, whatever you need to get this up and running on your service provider of choice. We also just created, like today, a Slack channel, which is called lyrasearch.slack.com. So again, if you need anything, just ping me here. I will try to answer as soon as possible. Before I finish my talk, I'd like to thank Nearform for multiple things. First of all, for letting me working on Lyra, for letting me being there today. I guess you already know Nearform. We are a professional services company. We hire in US, Europe, Brazil, Canada. So if you're looking for a fully remote job in a company that knows something about JavaScript, please reach out the booth or reach out after the talk. So that was all for me. Thanks. Thank you. And I leave my contacts just in case you want to reach out. Thank you.
Great. Thank you very much. So it's about lunchtime. We told them we'd be a few minutes early. So lunch will be where breakfast is, or was. Basically, follow the corridors and go straight out. If you don't know where that is, follow the crowd. We're probably all going to be like a herd. Yeah, it's lunchtime. I don't want to hold you up. I'm hungry.